All right. Welcome, everybody, to Standing for Truth. My name is Donnie Bedinsky, and it's a privilege to be your host and moderator for this exciting debate. Tonight, we're bringing you a formal exchange on one of the most iconic geological formations in the world and an intensely debated question on the origins discussion. What best explains the Grand Canyon? Representing the young Earth creation and post-flood catastrophe position is Brian Lauer, with Jackson Rowe defending the evolutionary and old Earth viewpoint. This should be a thoughtful and engaging exchange as both sides examine the geological evidence, the formation of the Grand Canyon, and the broader implications for Earth history and origins. It is a science-heavy and focused topic, Brian and Jackson. And so I do really look forward to seeing what kind of arguments and points you both bring to the table for tonight's great Grand Canyon debate. So if we could, let's break the ice and get acquainted before we get into our opening statements. Brian and Jackson, not your first times here on Standing for Truth, nor is it your first debate. Brian and Jackson, you both have been in the debate coliseum several times at least. Jackson, you've been doing debates here for years and years now, it seems. So this means, in a way, you're both pretty experienced, which is good. I think we're going to get a memorable debate here. So, Brian, let's start with you. You were just here. We're getting a bonus, 2 for the price of 1 deal, as last Saturday we did an impromptu show on Creation Science 101. We had a lot of fun engaging critics in the live chat. And now you're back here tonight. Time flies by when you're having fun, I guess. So, Brian, how have you been over the last week? And also tell us a little bit about yourself and your ministry.
Oh, I've been doing great. It was so much fun last week, and I do appreciate the critics tuning in. You know, that's a good thing to get all the information to make informed decisions, and things are going well. And I've got a ministry called Solidify Your Faith, where you can see some of these talks on YouTube. I give creation talks from Minnesota to Florida at churches, schools, colleges, conferences, you know, pretty much wherever God opens the doors, I like to go there. And I like to give people basically an opportunity to think. And you need to see both sides of a situation if you want to think, but that's not happening in our government, schools, museums, and media.
Brian Lauer, thank you for the introduction. It's also not your first time here. As I was saying earlier, for debates, you've been here for several debates in the past, at least one on this topic. And you've debated notable evolutionists like Planet Peterson, Mark Reed, and then the most recent one, Dr. Dino, on a very similar topic. So, Brian, for those that want to see more from you, I do want to encourage people to check the description box of this video, but also the live chat for my faithful mod, Doki Doki. I appreciate it, brother. We've got your channel and also your website there for people to check out. So thank you for being here, Brian. Jackson Rowe, great to have you as well. I just love and appreciate anybody. I respect anybody who's willing to go outside, whether creationists or evolutionists, outside their comfort zone, enter the debate coliseum or the debate dojo, and have an exchange or battle of ideas. Debating's not easy. If it were, everybody would do it. So I do really respect the two of you and just anybody in general. So, Jackson, how have you been since the last time you were here? You've had many debates with notable creationists, so this isn't your first rodeo. How have you been, Jackson? Also, tell us a little bit about yourself.
I've been doing pretty good. Been doing a lot of studying for this and a lot of fossil hunting and just geology, like looking for specific rock formations. That's how I got this poison ivy on my head. I don't know if you noticed that or not.
Oh, no.
Sorry
yeah,
about
that's
that.
what that is.
Oh.
Yes.
Can't see it, though. Anyway. Can't even notice it. Don't worry, Jackson.
You don't notice it. Well, that's good. But yeah, so I've been looking forward to this. So yeah, I mean, I'm a fossil hunter. Probably found thousands of them. That's the kind of thing I really like to talk about, the geology and paleontology.
Where do you
that's your vigilante superhero name, right, Jackson? The fossil hunter.
that'll work. Yeah.
Aren't they making a movie about you sometime, like the summer the Fossil Hunter, battling creation?
New Marvel character. I think
Right,
so.
right,
Yeah.
or DC.
Yeah.
Brian, my brother, you're gonna say something?
Yeah, yes. Where do you live? Where do you find these fossils?
I'm in Arkansas, so mostly Carboniferous period fossils is what I'm looking for around here.
Great.
We'll talk about that in a minute. Yeah.
I guess doing what you do, Jackson, and getting poison ivy, unfortunately, it's kind of the nature of the price you sometimes got to pay for the on the field research that you do, which means to the audience, we have Brian Lauer, who studied this topic extensively, Jackson Rose working in the field. My favorite kind of debates are debates where we have interlocutors that are informed, experienced, and that's what we have here tonight. If we're going to engage the Grand Canyon and get into geology and fossils and everything to do with it, it's much more edifying and thought-provoking when we have two individuals like tonight who have studied it so thoroughly. So for those that want to see more from Jackson Rowe, the fossil hunter, do please check the link here in the live chat, but also in the description box. This won't be the last you see of Jackson. As a matter of fact, we're working on setting him up for a future debate here with Dr. Jerry Bergman on fossils, and I'll be debating him on hominin, the human evolution in general, but we'll be focusing a little bit on hominins. Brian Lauer, same thing. It's not the last you'll see from him. He'll be debating Dr. Howard Feldman on the proper perspective of geology. I'm so glad that we got this debate, because very frequently I receive emails and messages of people saying, please, Donnie, set up a debate where you have the perspective of plate tectonics and the perspective of hydroplate represented. People want to see that kind of discussion. And so, Brian, thank you for being willing to engage in that. And of course, Dr. Howard F. in the future. So, okay, there's a little bit of promotion there for upcoming events with you two. We're well acquainted, Brian and Jackson. Anybody just joining us, we're debating the question, what best explains the Grand Canyon? As you'll see laid out, Brian Lauer takes the young Earth post-flood catastrophe position, but he'll go into the details on that. Jackson Rowe takes the old Earth evolutionary perspective. Format-wise, to make sure we're on the same page, we've got a formal debate for everybody tonight. 12-minute opening statement, starting with Brian Lauer. Then we jump into 8-minute uninterrupted rebuttals, where we get to respond to each other's points and arguments brought up in the opening statements. I'll give you gentlemen 1-minute warnings for each segment as well, just so you know to start winding things down. Then we jump into everybody's favorite part of these debates. We have a 50-minute cross-exam broken up into 2 sections, 25 minutes each for our debaters to lead the way in questions and picking topics. Then we've got 5-minute closing statements, good opportunity to wrap up our thoughts, wrap up our points, address anything we feel has been left hanging up to that point, solidifying our cases for tonight for the audience to examine. Then this is where we get the audience involved. We're going to hang out with the audience for 25, 30 minutes, depending on how many questions come in. So please, if you have a question, challenge, an objection, or a criticism, make sure you're professional, make sure you're cordial, as our debaters here tonight, Brian and Jackson, have been so generous with their time, not only for the debate, but the time leading up to it, which I understand requires a lot of time, effort, and work to prepare for. And tag me either at Donnie or at Standing for Truth. Super chat questions will be bumped to the top to guarantee that those specific questions are engaged. Okay, I think we're all on the same page, gentlemen, and ready to go. Therefore, I will get the timer ready. Brian, feel free to get your slides ready as well.
All right. Let's see the entire, and I just want to thank you, Donnie, for putting this together, and thank you, Jackson, for participating, and everybody who's tuning in. We hope we make it worth your while.
Amen.
And let's see here. Let's try playing this and see if you can see this. Can you see this?
Yes, that's coming in good, Brian.
All righty. Sounds good.
You do have that bar at the bottom. It's up to you. You can either click hide, move it away. I know the last time you tried that,
We'll try it. Cross my fingers.
Yeah.
And
it tends to do that, but it does remove it, so that's good. Maybe you just got to make your way back to it. There we go.
Now I think we got it. All right. I'm ready when you guys are.
Gentlemen, for the presentations, what I'm going to do is whoever's speaking, so in this case, Brian, I'm going to have you guys front and center with the other two of us backstage. So Brian, feel free to start whenever you're ready. I'll begin the timer on your first word.
All right. Well, we're going to be debating Grand Canyon and the features of Grand Canyon. So I want to show you what they are. Grand Canyon is 216 miles long, and it starts where the Little Colorado River joins the Colorado River, and it flows through the Kaibab Plateau. It doesn't flow around it, it flows through it. And then Marble Canyon is north of that. That's 61 miles long. And Marble Canyon is way different than Grand Canyon. It's narrower, it's steeper, and it's got side canyons that may be unique in all of the world. And then we've got the same elevation. You know, I encourage people to go into en-us.topographic-map.com. And then wherever you click, you can get the elevation. So you can play around with this, see if I'm doing it right. The river flows into the canyon at 3,100 feet, and then it flows out at 1,200 feet. And yet in the middle, the Kaibab Plateau, it flows through at 8,000 feet above sea level. So it's a mile above the river on the north rim. On the south rim, it's 7,200 feet above sea level. And then you just go around over here, that's 6,000 feet, 4,100 feet, 6,300 feet, 5,500 feet. And then on the north, it's even lower. 4,300 feet, 5,200 feet, and 4,700 feet. And then we have this funnel right here, which is, we'll zoom in on this. This is where Vermilion Cliffs and Echo Cliffs used to be joined at one time. And now this funnel is formed, and it's 18 miles long and it's 12 miles wide. And I took a picture from that direction looking at the cliff. And you'll notice that it's 2,000 feet high, and the layers tend to slope upward toward Grand Canyon. And those white spots on the bottom at the base of the cliff, those are houses. And then this is, if you want to see this picture, go into YouTube and Brian Nickel channel and check out the origin of Grand Canyon. He's halfway up Echo Cliffs, and that's 12 miles over there to Vermilion Cliffs. And those cracks in the middle, one crack is the Marble Canyon, and the other one is one of those barbed canyons. And then if you look up the funnel, that's 12 miles wide. And then to put it in perspective, this is what Grand Canyon would look like. Grand Canyon would be a drop in the bucket compared to that funnel. And then we got potholes on Echo Cliff. And potholes are formed when a rock gets in an eddy or a vortex in fast-flowing water, goes round and round and cuts into the softer sediment. And these potholes are 330 feet or 3,300 feet above the river on a 2,000-foot cliff over 4 miles away from the river. And then we've got barbed canyons. These are very unusual. It's like the tributaries are flowing one way, and then they do a U-turn. You notice here, the big picture here at the bottom, the elevation is 5,500 feet above sea level, and at the top, it's 4,000 feet above sea level. So the land is sloping to the north, and it drops 1,500 feet. And if you look at the individual canyons, this one drops from 5,500 feet to 5,300 feet, 4,700 feet to 4,500 feet, 4,600, and you get the idea. It's all sloping pretty much towards the north. And yet the Colorado River flows to the south. And then we've got side canyons. These are canyons that are just as deep as the river, and the northern canyons are longer than the southern canyons. And you've got the inner gorge, which is 1,200 feet deep through the hard crystalline rock, and that's a 46-mile gorge. And then you got a block near Isis Temple. It's 5 to 10 tons, and it's been raised up into sedimentary rock. And then you've got you got layers of sedimentary rock that are bent. And then you've also got a Grand Canyon caverns. They're 63 miles long. If you want to look at them, you got to take an elevator 21 stories down, and they're larger than 3 football fields. And then you've got Red Butte and Cedar Mountain, and these really aren't part of Grand Canyon, but they give a clue of how it happened. Red Butte is 1,000 feet of Mesozoic sediment capped with volcanic rock, and Cedar Mountain is similar, and you can see that from the Desert View Tower. And if you want to answer those, all you need for Grand Canyon is bulging and cracking 3 times. That's the key. 3 bulges, 3 cracks, and that explains Grand Canyon. But to set the stage, you need to have a lot of force to carve the Grand Canyon. Then that comes in the form of 2 huge lakes on the Colorado Plateau. Grand Lake's twice the size of Lake Michigan, and it's at 5,700 feet. So that's a mile in the air. That's tremendous potential energy, and it's incredibly deep. You know, you look at Grand Junction, Colorado, up on the right corner there. It's 1,100 feet deep. A little lower, Farmington, New Mexico, 350 feet deep. And then Page, Arizona would be 1,400 feet deep. This is a huge lake, and it's very deep. And Hopi Lake's about the size of Lake Huron. It's 250 feet higher, and those cities would be under 900 to 1,000 feet of water. And then once Grand Lake started to breach and go over Vermilion Cliffs, it cut a slot through there. And then a lot of water is cutting through the slot, so it cut down a little deeper. So you get a whole bunch more water going through, so it cuts even deeper. So now the water's flowing through like a torrent, and that's how you get the potholes to form. And then it cuts a slot down to the hard Kaibab limestone, which is 350 feet thick. It can't go any deeper, so then it spreads out and makes this funnel, and it removes all that sediment. So there's nothing pushing down on the Kaibab limestone, so that bulges and cracks. And then the river flows through that crack and undercuts Hopi Lake. And now you got two lakes that are catastrophically draining, just sheet eroding almost everything off of the Kaibab limestone, except for Cedar Mountain and Red Butte. And then not only does the Kaibab limestone crack, but the whole Kaibab Plateau bulges and cracks. And then the river flows through the crack to carve out the Grand Canyon. But before we get that, let's take a look at the barbed canyons. You know, that when that plateau bulged, now it makes the land slope to the northeast. And that's when the subsurface water flows downhill to the northeast, and then it hits that crack and turns around. And that's how you get the barbed canyons. And you notice here that the river's cutting through below the water table. So now you get a lot of water coming in from each side, and then it's bringing with it a bunch of sediment, and that's how the side canyons form. And you'll notice here it says that the north rim is roughly 1,000 feet higher than the south rim. So that's 1,000 more feet of water to drain down to drain out of there. So that's why the northern canyons are longer than the southern canyons. And then the water's gushing through, water coming out of the cliffs, and it's carving this caverns 66 miles long. And then it's carving through the Grand Canyon. And again, it's going down, hits the hard basement rock of the Grand Canyon. It should have got wider, but it didn't. And the reason it didn't is because now there's nothing pushing down in the Grand Canyon. So the basement rock bulges and cracks. And that's how you get the inner gorge. That's a 46-mile crack in the basement rock. And then how does the National Park System try to explain this? You can see this for yourself. Go into nps.gov. And it says the story of how Grand Canyon came to be, blah, blah, blah. The story begins, blah, blah, blah. So this is a story, folks. This is not science like we think of science. We think of things as that are observable and testable, repeatable, falsifiable, the double-blind type of science. And this is none of that. You know, that's all high confidence science. But what we're doing tonight, that's none of it. It is low confidence science. They call it a story. I'll call it a story. I'd like to call it science fiction. And the heroes of the plot are the Colorado River. Notice this. Scientists know that the Colorado River carved the Grand Canyon. Well, how do they know that? Were they there? Did they see it? You know, I'm here to tell you that there's no way that little river cut that canyon 10 miles wide. No way. So that's one of the heroes. The other hero is millions of years. Scientists have estimated an age for the river and thus the canyon through which it flows at 5 to 6 million years. So those are the heroes of the plot. But it actually admits on this national park website, perhaps the biggest question of all, how the Colorado River chose this course and began carving the canyon, still awaits a clear answer. So they don't know how it began. And perhaps the biggest question of all, I would disagree. I think it's, hey, how did this 5 to 10 ton rock get lifted up into sedimentary rock that's supposed to be millions of years old? And then how do these big layers of sedimentary rock bend at a right angle? And then it says the Kaibab Plateau, a high point through which the river gingerly slices, poses a problem for geologists. Well, I never saw that when I was at the park. It says, what's the problem? Water certainly doesn't flow uphill. Remember, it flows in at 3,100 feet above sea level. It flows out at 1,200 feet. And yet in between, the canyon rises a mile higher than the river. Rivers don't flow uphill. So that definitely is a problem. I'm glad that they admit it, but it's not very prominent. You got to dig to find it. And it says, while keeping these few accepted chapters in the Colorado River's history book in mind, remember those chapters are the river carved the canyon and millions of years, geologists have proposed a number of different hypotheses. So let's take a look at them. Number one, the Little Colorado River hypotheses. In order for this theory to work, the ancestral Colorado River would have needed to flow eastward over the continental divide. over that. Oh, there's no evidence for that, so let's throw that one out. And you got the northwest flowing river hypotheses, and in the red it says, unfortunately, no sedimentary deposits have been found to support this theory, so throw that one out. And then the spillover theory, the catastrophic draining of ancient lakes. Now that's the one I'm promoting tonight. You know, I agree with them, but they have the lake in the wrong spot. It says the Colorado River was temporarily damp behind the Kaibab Plateau. Well, if that's the case, it would have flowed around the north, which is thousands of feet lower than the middle, which is where the river cuts. So throw this one out. And then you got the collapse of a groundwater karst system. That's where I believe the water's coming out, gushing out of the cliffs, and eventually it collapses down and makes the canyon. But if that's the case, there wouldn't be potholes on Echo Cliffs. So throw that one out. And so I'm not here to tell you what to think, but I'm showing you where to get information so you can think. And I encourage you to go into creationsciencecenter.org and page 247. And you'll see this for free. It's Walt Brown's 9th edition of In the Beginning. And then you can see all the theories on the top and all the features on the side. And then it's red, yellow, green. Red means, hey, this doesn't work at all. Yellow means maybe it does. And green means, yeah, it sure does. And you look under hydroplate, it's green all the way down. And so we want you to get all the information. You could also go into Real Science Radio, rsr.org, and listen to Grand Canyon Month and see how the river couldn't cut the canyon and how it's not millions of years old. And also you can even listen to Walt Brown explain it. And so again, bulging and cracking 3 times. And I'm just going back to this one. You know, my brother-in-law was in a geology class at a state university, and they spent a week trying to figure out how Grand Canyon formed. And they looked at a bunch of theories, and none of them worked. And then on Friday, the professor said—
1 minute left.
Okay. And Friday, the professor said, you know, there's one theory we haven't talked about. Anybody know what it is? The kid raised his hand and said, no, it's flood. And the professor said, yeah, you're right, but we can't talk about it. You know, isn't that interesting? They don't have a theory, but they won't even discuss that. And to be fair, this is not right after the flood. Things had to solidify so it didn't turn into a big bowl. You know, the Kaibab limestone had to get hard. So I'm proposing that this was a few hundred centuries after the flood. And so to wind it up real quickly, you know, bulging and cracking 3 times. That's how you explain the Grand Canyon. You know, you had 2 huge lakes up there. Once they started draining, they bulged at the funnel and it cracked, and then it undercut Hopi Lake, and then it sheet eroded everything, called the Great Denudation. So then the Kaibab Plateau bulged and cracked. That's the second one. And then it eroded all the way down to the hard basement rock of the Grand Canyon. And so then the basement rock bulged and cracked. And that's how you explain Grand Canyon. And it just makes perfect logical sense. And I hopefully they'll put this on the National Park website, because the theories that they have there don't work, and they might as well put one of them, a theory there that does work. But I think we need more people to shine the light on that. So anyhow, that's the Grand Canyon in 12 minutes, bulging and cracking 3 times. Thank you so much.
Brian, thank you very much for that 12-minute opening statement.
Oh, and
to the audience, please make sure if you have a question or challenge, send those in. We will be doing an audience Q&A to the debaters. I know the 12 minutes do fly by, especially presenting on such a huge topic like this, the Grand Canyon. So Brian, thank you very much for that. Jackson, we will now reset the timer, and whenever you're ready, you have 12 minutes. I understand you want to screen share, so feel free to get to anybody just joining us as Jackson works at sharing a screen. We are in the opening statements right now. Brian just finished with his 12-minute opening statement. We have a 12-minute opening statement from Jackson. Then we jump into rebuttals of 8 minutes, a cross exam, everybody's favorite part of these formal debates, of 50 minutes, 25 minutes each, 5-minute concluding statements. And then we get you guys in the audience involved, where we get to interact with your comments and questions. So feel free to send those in. Jackson, I do see your screen ready to go, and I am going to put Brian and myself backstage. I'll start the timer on your first word. Go ahead.
All right, I got my timer as well. Okay, are we good to go then? All right. Grand Canyon. This debate for me is not so much about the Grand Canyon's formation as about all of the flood strata on Earth. The Grand Canyon's formation speed is pretty much irrelevant in my mind to the age of the Earth or the age of the strata. The age of the Cambrian to Cretaceous so-called flood strata, that's the question. Did it form rapidly or over vast amounts of time? So that's basically the gist of my presentation, what it's going to be about. Now, if all this strata is so young, deposited 4,400 years ago, 6,000 years old total, where's all the hafnium-182? Hafnium-182 can be created in nuclear reactors today, but it's never been found in our solar system, not on Earth, not in meteorites, not on the moon. It all decayed into tungsten-182 due to its short 9 million year half-life, so about 60 million years. I think it all fizzled out. Its daughter product, tungsten-182, can be found in very old rock samples as it's stable, so that proves that hafnium-182 was at one time there. I think that's a major problem for young Earth idea. Megabeds. Now this is what a megabed actually looks like. Brian showed one rock in there, so that to me looks like a piece of the formation below. I think that was a product of erosion, but this is what it would really look like. And here's the Tapete sandstone. So this is not a megabed, which really the whole Earth would kind of look like that in a global flood. Another thing that it would look like on the micro scale, it would have these cracks in all the grains because it would be a high velocity flow to account for all of the strata deposited, thousands and thousands of feet of strata over a 1 year period. So you're depositing all of this stuff really rapidly. So you get these cracks and fractures in all the grains consistently throughout pretty much everything. And it's there some places, but not throughout. Now, fossil record problems, this is where I got my poison ivy, as I mentioned earlier, starting to get into that. There's lack of angiosperm pollen in Paleozoic flood strata. So where is all of the angiosperm pollen in the Carboniferous? There's plenty of other, like conifer pollen, there's fern, Lycopsid spores, things like that. Lack of shark teeth or any teeth in Precambrian, Cambrian, or Ordovician strata. They're just not there. Shells are not in Precambrian. Why not? Trace fossils throughout flood strata, like trackways. How are these forming on flood strata in between other flood strata and not just being a soupy mess and getting destroyed? Not to mention the high velocity flow that would wipe them away anyway. Paleobiogeography, the lining up of paleoclimate, paleogeography, etc., with distributions of fossils indicating a time period and not a sorted flood layer. The plant Glossopteris is one of the most famous examples, but there are dozens of other fossil organisms you can do this with. And we're pretty good on time, so I'll keep going. Shark species of the Surprise Canyon Formation. This is a study done in 2018. We've got xenacanthomorphs, synacanthomorphs, Thrinacotis, Stephacanthus. It turns out all of these I've also found in Carboniferous strata here in Arkansas. These are microscopic teeth that I dissolved out of the Pitkin Formation, which is a limestone, so it's easy to dissolve. I dissolve it, sift through it, kind of decant all the vinegar out of it, and you see these black specks, and we put them under the microscope. This is a Stephacanthus tooth, Thrinacotis, and Bransonella. These were also found in that study from the Carboniferous Bright Angel, Surprise Canyon Formation of Grand Canyon. So these are all over the world, but only in the Carboniferous, and sometimes a little bit into the Permian with some of the species. Meanwhile, much later, after the Cretaceous period, we have these shark teeth that I found, Maniratotus. These modern shark teeth will never be found in similar Paleozoic strata. How and why? It doesn't make any sense. These are denticles, which are scales of synacanthomorphs from that same Carboniferous limestone in Arkansas that I mentioned, the Pitkin Formation. Those are also extracted in the study from the Surprise Canyon Formation in 2018. So why are there no anatomically modern shark denticles that I can find? I found one of these this morning, actually, a synacanthomorph denticle. Straight-shelled nautiloids, I found these in the Fayetteville Shale. Also found their disarticulated mandibles. That means separate from these shells, but they're the same organism. Now you'd think a giant shell like that and a tiny beak like that in the hydrologic sorting model would not be found together, but here they are. Microfossil conodonts, a globally predictable time scale of 1,000+ species, such as these Periodon on the left and Cladognathus on the right, in Ordovician and Carboniferous strata, respectively. I extracted these also. These species will never intersect, and many hundreds of other species won't intersect either. And there's really no explanation for that. They're the same size, same density. They lived in probably similar environments. So there's no real explanation other than deep time. Now, I mentioned Glossopteris, the plant, the paleobiogeography of the Permian period. That's when we had the supercontinent. All the continents were joined together. And if you look today, that distribution doesn't make any sense. We've got them in South America, India, Australia, Antarctica. But if you join those continents and land formations together, suddenly it makes sense. And that also applies to a lot of therapsid species from the Permian, and some also amphibians and reptiles otherwise. Now, basically, the fossil layout of the Grand Canyon, the Coconino Sandstone at the top, and the Permian, we have vertebrate tracts. Surprise Canyon Formation, the Carboniferous, we have shark teeth. The Bright Angel Shale, which is Cameroon, we have trilobites. We don't get those things intersecting. Now, then there's the Great Unconformity. That's when they say that the flood started. Below that, though, we have the Bass Limestone, and we have fossil stromatolites, which are algae colonies. So fossils are forming there, or they did form there in the Bass Limestone. But so why are there no shells? Why are there no shark teeth? Why are there no trilobites? Where's all that in the Bass Limestone? And what makes these flood layers so good at allegedly fossil preservation? But for some reason, we say, or the creationists say, that Bass Limestone wouldn't have been able to do that. But yeah, it has fossils anyway, so that's not a good argument. Aeolian, fluvial, and evaporites can't be explained in a flood. I'll just skip this slide for now. Anyway, trace fossils, they don't work in a flood model. Given the entire Earth was completely submerged, there's really no way for vertebrate tracts to make any sense. And yet we have vertebrate tracts here in the Coconino Sandstone. Genesis 7:19, and the waters prevailed exceedingly upon the earth, and all the high hills that were under the whole heaven were covered. Now, even if the high hills were 10 feet tall, still too deep for anything to walk and make these tracks. Not to mention we have Aeolian, which are land-formed deposits in 4 formations. The Coconino, the creationists kind of contest that, but they don't really talk about the other 3. And in these land formations, we have vertebrate trackways. We have inversely graded wind ripples, lamina, which the top sediment gets blown off, the lighter grains, and leaving the heavier grains. There's a list of Aeolian deposits of North America alone. You have to explain all these, not just the Coconino Sandstone. Then we have mud cracks. This was sent to me by an Arkansas geologist. This was in the Ordovician limestone of the Everton, Powell, and Platten formations in northern Arkansas. Now, even in modern lime tidal flats, they'll occasionally dip below the tide and dry out and crack. And that's how desiccation cracks or mud cracks form. There's no really other way to explain this. So during the flood, smack dab in the middle of the flood strata, you have mud cracks. Now here's more of them. This is from Colorado, Montana, cross section there, Indiana, and Maryland. They're everywhere. Fossil raindrops and vertebrate tracts in Carboniferous strata in Alabama. That also can't happen in the middle of a flood strata. How does that work? And raindrop prints are pretty common too. Not common, but they're not rare. Now the most common of all, ripples, fossil ripples. Asymmetrical ripples and symmetrical ripples. These indicate a slow current, and asymmetrical, as in this one, they indicate a directional current. It would be flowing from left to right here. I actually took this picture. It's about 5 miles from here, where I am now, in Carboniferous strata. Now again, in the high velocity flow of the flood, any ripples really would have been sheared flat, because too high velocity flow that doesn't produce ripples. Fossil ripples with trace fossil Cruziana that I've located. You can see it here. My arthropod crawled over this ripple mark here, which, how did you get this detail and this amount of chaos? And probably worst of all, I found these symmetrical ripple fossils in Carboniferous Hartshorn sandstone. These form in back and forth waves like near a shoreline. I took this picture near the Arkansas River. These are modern symmetrical ripples. These form when the waves are going in and out up to several feet out in the river. So basically, we have something that can't exist in the middle of flood strata, yet here it is. And here's a modern example. So invertebrate trackways sandwiched between flood layers, the Kaibab and Redwall limestones, plentiful rocks and boulders distributed across strata as a mega flood would produce. Brian showed one, but again, it's the piece of the formation below it stuck in the formation above it as a result of erosion, I believe. Aeolian deposits throughout strata, the order of the fossil record, and animals and plants alive today that should have died out, like cicadas. I'll briefly go into that because I have 40 seconds left. Cicadas, they live underground as larvae for at least 2 years, some longer. They lived as adults for 6 weeks. So their larvae would have drowned, and the adults couldn't breed during the flood. So the fact that cicadas still exist, it doesn't make any sense. So the flood never happened, based on the evidence I'm seeing. So with that, I'll go ahead and stop sharing the screen.
Jackson, that is 12 minutes roughly. That concludes your opening statement, and that concludes our opening statements for tonight's debate on the question, what best explains the Grand Canyon? We're now moving into rebuttals of 8 minutes for the both of you to respond to each other's points and arguments brought up in the opening statements. To the audience, reminder, if you got questions, challenges, or objections to anything said or any point brought up during tonight's debate, send those in the form of questions and we'll have some fun interacting with them. Brian Lauer, I will reset the timer and you have 8 minutes starting now.
All right, let me share my video real quickly. Yeah, you brought up a lot of neat fossils and stuff. I really appreciate that. I just was wondering if you had found any transitional ones. Let's see, the block that you had mentioned before. Yeah, you're you're right. It did come from that bottom layer, but you said it came from erosion. And how could that erode upward? Especially if those layers are supposed to be laid down millions of years. You know, how is it going to get up there through all that hard rock over millions of years? So that would be a question that I would have people consider. And then you notice that these layers, like the Coconino sandstone, like he talked about, that's not just at the Grand Canyon. That's all over western, or not, it's all through over like a western third of America. And it says that the Coconino sand grains and the Coconino sandstone came from the Appalachian Mountains. So I got a question. How do you get sand from the Appalachian Mountains across the Mississippi and over the Rockies to get over to Arizona? I would say that could happen with a worldwide flood. And I don't see how that could happen over millions of years. And then he talked about these layers and the big mega sequences. Again, they're not just at the Grand Canyon. This goes all over North America. That one's all over North America. How do you lay down layers of stuff all across North America? You can't do that with a local flood. And I would say this needs to be a worldwide flood because not only are they all over North America, they're all over the world. This Sauk mega sequence, Tim Clary's done some excellent work on this. It goes all over the world along with this mega sequence and that one. These are worldwide layers of sedimentary rock. How do you they had to be laid down all at once like a big pancake. How do you do that unless it really was a worldwide flood? And then you talk about these layers and how they're supposed to be millions of years old. And well, why isn't there any signs of erosion? There's erosion at the top, but not at the layers. If that river cut that canyon over 6 million years, shouldn't there be some other canyons going in the side there? Shouldn't there be some layers on the side? And then how do you get slanted layers underneath the flat layers? If those are millions of years old, and then how do you get that formation? And what I noticed you didn't say, you did mention the Ordovician. Okay, the Ordovician, notice they're not there in the Grand Canyon. So where did the Ordovician layer go? From this table, it's 70-some million missing years. And it's interesting, on the Grand Canyon website, it says, this is a screenshot, it says layers from the Cambrian, Devonian, Mississippian, Pennsylvanian, and Permian periods are present. Well, yeah, that's true, but what they're trying really hard not to tell you is that the Silurian and the Ordovician are missing. You know, that's kind of hard. If those were laid down over millions of years, and then not only that, it's 2/3 of the Devonian are missing too. So Brian Nichols shows this, there are 100 million years missing from that geologic column. And I submit to you that that geologic column does not represent millions of years. And you can do an experiment, you know, that dead deer on the side of the road, is that going to turn into fossils? No, you know, it's going to get scavenged. It's going to decompose. The only way it turns into a fossil is if it's buried rapidly. And therefore, any layer that has fossils in it was laid down rapidly. And that's the whole geologic column. They were all laid down rapidly if they got fossils in there. And you notice these layers here. You got the Coconino Sandstone is separated by the Hermit Shale 70 miles away from the Grand Canyon. And yet they're touching each other on the Grand Canyon. And I think the premise that those layers represent millions of years is flawed. And also there's billions of years that are missing. It says that 500 million year old Tapete Sandstone is directly overlaying the 1.4 to 1.8 billion year old Vishnu schist. So that could be a billion years missing. And so again, I think that time frame, I think that's a flawed way of looking at it. It says, think of the red bluffs and cliffs of the Grand Canyon as Earth's history textbook. You can jump back almost 2 billion years into the planet's past, but that textbook is also missing pages. In some areas, more than 1 billion years worth of rock have disappeared. You know, how old is the Earth? 4.6 billion. So you're missing 1 billion years, a fourth of the Earth's age. So that's a problem. And again, you see this here, but you don't see this in the textbooks. You don't see this at the park. And then now you talked about ripples and footprints. You know, what process today, let's see, I can stop sharing that for now. Ripples and footprints. What process today is preserving footprints? You know, where? Show me where raindrops are being preserved. And if you read Walt Brown's book, and people can see that, his 9th edition for free at creationsciencecenter.org, he talks about how you get those ripples, how you get those footprints. Because he talks about when the plates are fluttering during the flood, the water's shooting up and the plates are going down. Well, then they're going to rise up out of the water. It's muddy water, full of sediment, a lot of cementing agents there. And they're going to slowly rise up, and the animals are going to run there to get air, you know, and they're going to make the footprints, and then it's going to sink down. And then the muddy water can come over and fill it in with some sediment that preserves it. And then you never find you don't find the animals with their footprints. Typically, you find them in the layer above. You know, how does that happen? So that's a question that I think the worldwide flood can explain how that's preserved. And they found dinosaur footprints on every continent, including Antarctica. So what happened? It had to happen all over the world to preserve those footprints, because it's not happening today. You know, you walk in the beach today, it's gone. You walk anywhere, it's gone, unless it's in cement. And I think that's what happened during the flood. And you got these layers of sedimentary rock. My question is, well, hey, what cemented them together? How did it get so evenly mixed with cementing agents? And I think that is clearly there was a flood that had lots of those chemicals in it. And then as it dried out, then it turned into stone, because those sand dunes, they're not turning into rock today. You know, you needed a special event to make all this stuff happen. And it appears that special event happened all over the world as evidence of the dinosaur footprints. And I would encourage you, you know, it just seems like the worldwide flood makes a lot more sense than millions of years of erosion, especially when the Grand Canyon, which is what we're supposed to be talking about tonight, is missing 100 million years from that geologic column. And you got the Snebly Hill, 800 feet of it, 70 miles away between the Coconino and the Hermit Formation. So yeah, that's let's see. Yeah, that's interesting. Let's see if I got any other slides here. But yeah, I do appreciate all those fossils that you did find. Again, my question to you is, did you find any transitional ones? Let's see what we're doing here. Try and see if I got anything else. Okay, the ripples and the footprints. Oh yeah, and then, you know, the radiometric dating. I've got some questions on those. I think that one experiment is worth 1,000 expert opinions. Okay, and they tested the lava flow from Hawaii when they knew when it erupted, you know, 200 years ago, and they sent it in, and it gets an age of 1.6 million years ago. And then the same thing yet 22 million years ago. So when we know the age of the rock that was tested, it doesn't work. And we're supposed to believe it when we don't know the age. And they did the same thing with Mount St. Helens. You know, Mount Etna, they had, again, these are all within, they know when the rock was formed during the eruption, and then they test it and you get 250,000 years, 300,000 years. And so my suggestion is those things are not accurate. They're based on
30 seconds left.
Okay. And then, and Mount St. Helens too, they did the same thing. The rock should have been about 10 years, but they send it in and then they do all these different dates and they get wild results, anywhere from 340,000 to 2.8 million. So again, if we know the age and it doesn't work, why should we believe it when we don't know the age? Because they don't know the initial condition of the rock. They don't know if the decay rate's been constant for millions of years, and they don't know if it's been contaminated with water. Thank you very much.
Brian Lauer, thank you very much for that rebuttal, that 8-minute rebuttal. Jackson, we're going to reset the timer. You now have your 8-minute rebuttal. I'll get the timer ready and start it again on your first word at any point during the debate, just like Brian did. If the screen needs to be shared, just let me know. Okay, the floor is yours, Jackson.
All right. I don't think I'm going to share my screen yet. We still have the cross exam, right?
Yes.
Okay. Did I find any transitional fossils? Arguably, yes. The plant Cordytes has characteristics of early gymnosperm, but isn't quite a conifer yet. I mean, so it looks transitional. So, and I found hundreds of those. But anyway, how did the Coconino sandstone sand get there from the Appalachians? Well, wind blows sand hundreds or even thousands of miles. So that's another explanation for that, not just water. Mega sequences, he mentioned. Mega sequences, I mean, that's kind of can be explained by distributions of oceans over certain periods of time. Like each, Silurian, Devonian, Carboniferous has different distributions of these sequences because of the distributions of deposition related to the ocean or erosion. Now he said there's not really any erosion in the Grand Canyon. There's something like a dozen or so somewhat unconformities. I don't remember the exact number. The Great Unconformity has meters of regolith around it, indicating it was eroded over long periods of time. Now he showed the Coconino sandstone and the Hermit Shale outside of the Grand Canyon where it has the sequence in it that I can't think of the name of right now. And he says, where is that sequence in the Grand Canyon? Well, he kind of just proved it got eroded out of the Grand Canyon, didn't he? He found it, but somewhere else. There it is. It's between those two layers. What else is it? It just got eroded here. He said 1 billion years have been eroded from the Grand Canyon, but if you go north to Canada, it's 600 million years it's been eroded, so it's not even. The erosion's not even. Now, he mentioned dinosaur footprints, and he says, you find them all over the world. That's true, but where do you find them? You find them in Jurassic and Carboniferous strata. In Cretaceous strata. Will you ever find them in Carboniferous or Devonian strata? You don't. Fossil formation. Is it happening today? That's a big contentious issue with creationists. I don't really understand why. I mean, Noah's flood is just a bunch of water and mud, basically. Why is it special? That's happening today too, just on a smaller scale. Or even if Noah's flood did happen, that's still happening. I found subfossil Corellia shells in Kauai. They have varying degrees of fossilization. Some of them still have coloration. Some of them don't have coloration because they've been buried for however long, but not that long, but long enough to where they're starting to fossilize. And if you leave them for a little while longer, they will fully fossilize. There are all levels of fossilization going on in the world. It's not just me saying that. And he mentioned the radiometric dating. Now, he showed recent lava flows that have been dated with potassium argon, which has a half-life of something like 1 billion plus years. I don't remember. But with that amount of time that's elapsed, it hasn't formed enough of the daughter product from decay to make any sense to use that. So they used it on the Mount Vesuvius flow, which had just enough amount of time to accumulate enough detectable daughter isotope, and they get within roughly the calendar year 79 AD of Mount Vesuvius. But if you date random things that just erupted, yeah, that's not going to work with potassium argon or really much of anything. And you talk about Noah's flood being this special event. Okay, what makes it so special? Why is the supergroup below it not special? Why? I mean, there are fossils in the supergroup below the Bass limestone. Why they're not more? And there are Ediacaran, which is late Precambrian fossils that are soft-bodied, and they don't like to talk about those. But anyway, that's what I've written down. So we'll go into cross-exam here in a minute, I guess.
Jackson Rowe, thank you very much for that roughly 4 to 8 minute rebuttal. Gentlemen, we're moving along smoothly. That wraps up our opening statements and rebuttals. We have plenty of points now on the table to go back and forth on and directly engage in our cross-examination period. We have lots of time to do this. 50 minutes in total. We're going to break it up into two 25-minute sections where you both get that opportunity to ask your questions and pick what you feel are the most relevant and important topics. Jackson just wrapped up his rebuttal. Therefore, let's give Brian the first 25 minutes to lead the way in cross-examination. Gentlemen, the floor is yours. Brian, go ahead.
Okay, yes. Can you see that slide at all? Can you see that?
It's coming up.
Yeah, it should be up now.
Okay, yeah. To form the Grand Canyon, you have to remove 1,000 feet off of 10,000 square miles, and it's called the Great Denudation. How did that happen?
I have no idea. I haven't looked into this particular topic, but my idea is that it's not really super important how the Grand Canyon formed, if it formed rapidly or over millions of years or an intermediate amount of time. The Earth is still old.
I'll ask. Okay, I think it is important because they're proclaiming it that it's millions of years, and I can show how it can happen very quickly, so that millions of years is not necessary. Why are the North Canyons bigger than onto the south of the canyon?
I would suspect it's because of the higher elevation to the north that causes faster runoff.
Okay, and so those side canyons, if the river cut the canyon, what cut the side canyons? They don't have a river.
The runoff.
But they don't have a river. There's not enough runoff to cut that deep.
You don't need runoff. You don't need that. You don't need a river for that.
Well, then why aren't they that? Right, but rain is not going to do that. Well, anyhow,
the vast amount of time it will.
Why? Okay. Why aren't there Grand Canyons? And going back to that, if rain will do that, why don't we get Grand Canyons everywhere on every river?
Well, the Kaibab Plateau was uplifted, so I suspect that has something to do with it.
Yeah, I would agree. Yeah, and why does the river?
There are quite a few canyons associated with coincidentally areas of uplift.
Right, but not. Okay, so why did the canyon flow through the Kaibab Plateau instead of around it?
Because it wasn't always that high.
How do you know that?
Because it's uplifting, even now.
Well, yeah, but the river could have gone over. Why did it go through the middle?
Why it could have gone to the left, it could have gone to the right. It just happened to go through that part.
Okay, just so story. Okay, so how does this happen? You're saying that the river was there before the uplift? Is that what you're saying? And then it just kept on cutting it as it was uplifted?
Yeah, that's the scenario you didn't talk about of the hypothesis. I noticed you left that one out.
Well, I got it from the website. So the website, I went through everything that's on the website. And are you aware that there's 75 feet of boulders and silt at the bottom of that canyon? The river's not cutting the canyon anymore.
The river is cutting the canyon, just very slowly.
Not through 75 feet of boulders.
That would take very long, but yes, it's still cutting it.
Okay, we'll move on. Okay, why'd the river cut down into the hard crystalline rock of the inner gorge instead of getting wider in the softer sedimentary rock?
I suspect because, like I said, it's still cutting through it. I mean,
but it should have got wider. Should it? Will a river erode the soft stuff first or the hard stuff first?
Well, if we're picturing this, you're asking the bottom to erode outward and not have the top collapse down. So as this widens, you're getting the sides falling in also, right?
Well, as it widens, it should be flatter. It should keep getting wider instead of deeper. All right. What formed the funnel?
The funnel?
Yes.
I don't know. It looks like the Colorado River to me.
Okay. Why do the layers slant up toward Grand Canyon?
Probably tectonic activity.
What is the force? What is the mechanism? What is the energy to push them up?
Plate tectonics.
That's a name, but what is the force? What is the force that moves that up? What's the mechanism?
The mechanism, you're just trying to get me on a technicality of what that's called exactly?
It's called gravity. Gravity is the force. Hydraulics is the mechanism. The mountains are sinking down and it's squeezing lava to the side, and then that's pushing it up, and that's the mechanism. And the hydroplate theory explains that perfectly. How do you get?
Recreationists don't like hydroplate.
How do you get potholes on a 2,000-foot cliff, 330 feet, and 4 miles away from the river?
Well, I don't know exactly what that formation is, and I suspect it's not what you're saying it is, though. But I really don't know.
Well, this is a PhD from MIT who's saying that this is a pothole.
Well, it maybe is.
He's brought geologists there also.
Well, it might be.
Why is Marble Canyon so much different than Grand Canyon?
Let's see. Looks like it's a higher elevation area. It's probably flowing down a little faster.
Actually, it's lower than the Kaibab Plateau. I mean,
it's
right.
Lower. It is.
Yeah.
Well, that would also explain it. I guess it's a different elevation.
Okay. And how do you get barbed canyons? How do you get them to flow towards the north and then turn around and then flow to the south?
It looks like runoff again.
But why? I mean, the slant is going to the north, but that the river is going to the south. The land itself is slanting to the north. And when my brother-in-law was in his geology class at a state university, he said, this is one thing we could never explain. So how would you explain it?
I don't know, but I suspect it's runoff.
Okay. Well, this is what runoff normally looks like. This is the Amazon. They're all pretty much going to the west. And if you look here, they're going opposite directions. Okay. And why are there downward arched layers in the barbed canyons? You know, if those layers were formed over millions of years and they're nice and flat, why are these slumped down?
I don't know, but let me ask you a few questions.
Well, you'll have time to ask your questions.
All right, we're doing okay. I forgot.
Are you familiar with Nankoweap Canyon?
Not really.
Okay. Notice how there's all these side canyons. That's Nankoweap Canyon right there to the west, but there's virtually none to the east. Why is that?
Is that the Kaibab Plateau right there?
Yes.
Yeah. Well, I would suspect runoff again.
Okay. All right. And then this is a zoom in on the Nankoweap Canyon. And how do thousands of large rounded boulders get 200 feet high along the creek?
Well, I haven't seen a picture of it, but I would suspect they were eroded out and they were washed in by the river. Okay.
And the river that's below it.
Yeah, again, I don't know. I haven't seen photos of it.
All right. And then over here where there aren't any canyons, it's at 6,000 feet of elevation. The river's at 2,700 feet. That's at 4,500. And this is Nankoweap Mesa, 6,200. So 2,000 feet above the surrounding area. And on top of it, there are slumps, landslides, and rock falls. How would that get up on there?
Well, if that was that one rock you showed from the formation below it, that action of the two layers going across each other like that will roll it up into the other formation.
So you still think that 5 to 10 ton rock got lifted up into sedimentary rock by erosion? Is that still your position? Okay.
Yeah, I do.
All right. Okay. So then it drops down to 4,100 feet. And then you get to Nankoweap Butte. Okay. This is 5,100 feet. How did that form?
That I don't know.
Okay.
But I suspect.
Right. And then this is that rock that we talked about, and you think that eroded up through millions of years of rock. Is that still your position?
It probably got rolled up as that formation was rubbing against the other one. Yeah.
It got rolled up there.
Probably
How long did those layers take to form?
A long time.
Millions of years, maybe?
Sure.
So how would a rock get rolled up through millions of years of rock?
Well, like I said, it's rolling through it.
Rolling through it, but you don't see the broken. You don't see the broken. You don't see the broken layers. You don't see the rock broken on the path as it rolled up.
Now, if it was just some random rock that was not part of the formation below it, I'd say you have a point. But I mean, I don't see the other explanation.
All right. And then how did Grand Canyon Cavern form? This is 63 miles long. It's 1,500 feet below the surface, and it's 24 stories deep. How did that form through limestone?
Well, how did any cave form through limestone? There are limestone caves everywhere.
Yeah, it's because of the flood. The flood laid down the limestone, and then the waters gushed through it and carved it out. And then you get the stalactites and stalagmites forming after that. And the interesting thing about this is the largest dry canyon in the U.S. And this is huge. And then the other question is, where did all the limestone come from? You know,
that is a good question. Because limestone doesn't form rapidly, as far as anyone knows.
Exactly. And Dr. Walt Brown, he asked Bob Dietz, he's one of the founders of the seafloor of plate tectonics. He coined the term seafloor spreading. And when limestone forms, it releases carbon dioxide. And there's 600,000 times more limestone on the surface than carbon dioxide in the air. And so then he asked Bob Dietz, where'd all the limestone go? And you gave the right answer. Bob Dietz says, beats the blank out of me. And yet the hydroplate theory can perfectly explain how limestone formed. And this is what I was
You're saying that the amount of carbon dioxide in the atmosphere today is related to the amount of limestone in the rock?
Well, that's what it would happen. And you can ask me those questions during your Q&A.
Right.
Okay, the Redwall limestone is 500 feet thick, and it's supposed to be 50 million years old. So it's going to do 1 inch every 8,000 years, roughly. So my question to you is, how do fossil nautiloids form? They're in the bottom of the Redwall limestone, and there's billions of them, and they're all pretty much oriented the same direction. And some of them are standing vertical. Okay, about 15% are standing vertical. And if that formed at 1 inch per 8,000 years, how is that nautiloid going to stand vertical for 100,000 years?
Well, you don't have to form it at 1 inch per million years. You can form sections of it faster than that. And this could be what's called a deathbed. You're familiar with that, I'm sure. Yeah. But the thing about cephalopods, they breed all at once and then die. Like that shell I showed in my presentation, I found it alongside a bunch of other ones. And occasionally you'll find one that's 9 feet long, way bigger. And the thing about these is they always have a broken apex of the shell, and evidence suggests they were infected with nematodes, which made them sterile.
So how could they stand? So you're saying that they could have got buried rapidly. Is that what you're saying?
Yes.
Okay, we agree on that point. Okay, how do you fold layers of sedimentary rock?
Over long amounts of time with large amounts of pressure and heat.
Wouldn't they break?
And they did. Even Snelling slides showed fractures in the midsection there.
No, I would disagree. The layers themselves, the layers between them may have broke, but the layers themselves are still smooth. And the pressure and the heat, that would have turned them into metamorphic rock. It would have turned sandstone into quartzite, but it didn't. They did
this. You didn't have to have a huge amount of heat to do it. You can bend
right, but they're not bent or they're not cracked. They were bent when they were still soft, and then they got hard. And they compared them from when they were flat to where they were bent, and they looked the same. So that heat and that okay. And then again, and you said that there's erosion everywhere, or there's erosion in those layers. I don't see it. I mean, you say that the whole layer's gone and got eroded away, but what about erosion at the time between these layers? They're incredibly flat. Wouldn't it rain a while to make gullies? I mean, you look at the top.
There are paleo valleys all through that, and there are sections of it where you can see uneven strata. You just select the ones that don't show that.
Where's the valley? I mean, you look at the top of Grand Canyon and you can see it's jagged where there is erosion. But when you look at the middle of the Grand Canyon, You don't see those jagged stuff.
Well, why aren't valley desert plains and plains? Why are they flat? That's kind of like
Well,
asking.
you can ask me when it's your time. Okay, and then how did this happen? You talk about the great unconformity. Well, yeah, how do you get slanted layers underneath the flat layers?
Well, this was a different time period. The great unconformity kind of proves that because it's missing vast amounts of time, as you pointed out.
Yeah,
this area was subject to plate tectonic event, and it's slanted. And the top section, the above the great unconformity, wasn't yet.
So how do you get the flat layers on top of slanted layers? Why are they slanted? Why are they beveled off so cleanly?
Erosion.
No, erosion would make valleys, like a river, like the Grand Canyon.
You make very smooth surfaces too.
Where? I mean, you're gonna those layers you're saying are millions of years old, and they just happen.
Yeah, well, the great unconformity was a time of a great uplift, and there are sections that are sheared, polished flat.
How did they get polished flat? How did they get sheared off?
By erosion.
Well, where does that happen today? What's getting sheared off today by erosion?
Well, I mean, you're thinking you want to see it now. I mean, it doesn't happen in a human lifetime.
Well, anywhere. I mean, you see the rivers cutting down. You don't see huge tens of thousands of square miles getting sheared off.
Well, you see plates moving all the time. I mean, you don't see them, but there are plates moving.
Plates can move, but that doesn't shear them off.
Well, it can cause areas to. Yeah,
it shears the side of them. It can shear the side of them, but it doesn't shear off the top of them.
If they go over each other, it does.
So that's what you're saying here, that all those layers went over the other one and sheared them off?
That's what the great unconformity kind of indicates, the great area of erosion.
Well, I would say it indicates that there was a big compression event and the basement rock buckled, and so the layers on top of that buckled, and then that compression event, they still kept going, and the layers that were on top of it sheared it off. So that's another perspective. Do you think people should be able to see two perspectives or just one?
Well, if you have good evidence, you should see both perspectives.
Yeah, I would say so. Yeah, if you have good evidence, and I would say even if you make accurate predictions, I think that would be a good starting point. Are there any accurate predictions that your worldview makes? Or has made?
The whole fossil record.
So what do you predict? What prediction did they make, and what turned out to be true?
I would eventually predict, well, to go the other way with it, I would eventually predict to find a shark tooth in the Cambrian or the Precambrian, and no one ever has.
Okay. So that's one prediction that they have. Are you aware of any accurate predictions that has been made using your perspective of the past?
Well, if you look at molecular clocks and dates of transitional fossils, they seem to line up.
Well, that's not a prediction. What would they predict to find before they found it? Do you have any documented predictions and then document validations of anything like that from your perspective of the past? Hello? Hello, is anybody there? Can you hear me, Donnie?
Oh, I think Jackson may have frozen because I don't see him moving at all, which means I will pause the timer and give Jackson an opportunity to make his way back in. I've paused it at the 17-minute mark. To the audience, I am all caught up on your questions and challenges. Keep those coming in if you can. That way we can help to make this debate that much more comprehensive. Okay, as we wait for Jackson to make his way back in, he'll probably want to reset his system and plug in the Ethernet cable again. And so in the meantime, I will go over some announcements and reminders. Our latest episode with Dr. Dino, Creation, the Flood, and the Coming Judgment, is now available for all ministry partners and Team SFT patrons. Big questions answered This was a thorough program. It was a ton of fun. We got to expand on our previous episode from last month, The Big Picture, Creation, Evolution, Salvation, and End Times. Those episodes can be found on Patreon, our Patreon page, and that includes our ongoing Genesis Revealed series. We've been busy this year with this series, recording roughly every few weeks. We are already on episode 10. If people are enjoying this debate as much as I am, we have Brian Lauer back with us in August for a debate against Dr. Howard Feldman. This should be another technical showdown on the proper perspective of geology, plate tectonics, or hydroplate. Last Saturday night, Creation Science 101, Brian Lauer and myself had a ton of fun with this program. It was very interactive. We had a great live chat with some good questions and challenges that we had the opportunity to engage. And don't forget to follow us on Facebook, as we just hit 105,000 followers. We're growing fast, and praise the Lord, we can spread the information to so many people. On Facebook, you'll find a lot of exclusive content that you won't find anywhere else either. Okay, looks like Jackson is back. Jackson, good to have you back.
We had some
As
tech
debate.
difficulties there.
No worries. No worries. It was a good opportunity to go through some announcements and reminders. I've always got those ready to go just in case. But I'm glad you made your way back in, because excellent debate so far. I love the fast-paced cross-exam. This really is a lot of fun. A good word to describe it: stimulating. Very stimulating debate so far. So, Brian, we are going to start off at the 17-minute mark, which means you've got 8 minutes left to cross-exam Jackson Rowe. Feel free to reiterate that last question if you'd like, and share your screen. I can get that back up so we can continue here.
Sorry about
Okay.
that.
No, that's fine. That happens. We'll just keep moving on. Where are the millions of years of talus that are in the Grand Canyon?
Brian, do you want your screen shared for this or no?
Yes.
Okay, I think you might have ended the screen share, so feel free to
Okay.
re-screen share.
All
As
right.
you do that, reminder to the audience, it's a technical topic, so we're not expecting a ton of questions like we might get with just more general topics, but do make sure if you got something on your mind, or you hear something that Brian says or Jackson says and you disagree with it, or you have something of clarification, send that in. We've only got a few questions so far, and we do have roughly 25 minutes for the Q&A. So, okay, Brian, I see your slides at the bottom. I got that up now. And reminder, you just hit the 17-minute mark. The floor is yours. Go ahead.
Okay, where is millions of years of talus? That's stuff that breaks off of a cliff. And as we went up Glen Canyon, our river guide said that's fresh talus, because that hasn't got the varnish that's formed on it. So that was fresh. But there's not millions of years of it. Why is that?
You see that river below there?
Yeah.
Yeah, it got washed away.
All of it. Well, it didn't wash. It didn't wash away Nankoweap, that delta. You know, if it's going to wash away millions of years, it should wash away that Nankoweap Canyon delta, but it didn't.
Well, deltas are deltas. I mean, this is.
Well, no, it's just the side of the river, you know.
Yeah.
Okay. Where did all the sediment go?
Probably the ocean.
There should be a huge delta. There's 800 cubic miles that are missing from the Grand Canyon.
Well, there is a delta.
Well, there's not 800 cubic miles of it. There was a guide who gave tours there, and he'd always give people a tour, and he'd say, you know, I dug it. And then a kid asked him, where did you put the dirt? And he said that question haunted him the rest of his life. That delta is not big enough.
Wouldn't this apply to your model too? Where is the dirt?
Oh, yeah, I can show you that. Yeah, that's, let's see, that would go down to, well, I suppose, let's see. Yeah, I can show you, or I can show you when, right here. Right here. It flowed out with such tremendous force. There's a huge floodplain on about 100 miles on either side of those rivers, on 100 side. And then it got pushed way out into the Gulf of California, that little river, and you got huge boulders.
My answer too. It's just you have the same answer.
No, your answer, it should all be like the Mississippi Delta, where it's all fans out like this. This one went straight way out there, but we can do that later. Let's see. And you talked about how does a little river cut a canyon 10 miles wide? Why don't all the rivers have canyons 10 miles wide?
Uplift.
Uplift?
And downcut.
Uplift and downcut. What was the force that uplifted it? What force lifts a plateau a mile in the air? About the size. Well, that's not a force. That's just.
What do you mean? What force? You mean like the strong nuclear force? That's not.
No, I'm talking like gravity. Gravity could be the force, and the mechanism could be hydraulics.
Well, that's kind of the opposite of gravity. It's pushing up.
Well, you understand hydraulics. You push down on a big thing and it pushes a little thing up. The big mountain's pushing down and the plateau is pushing up. Okay. And then you said that this Schnebly Hill Formation, which is 800 feet to 1,000 feet thick, just eroded away in 70 miles. It's just not there. You think that just got eroded away?
Apparently it did, because there it is there and there it isn't in the other spot. But there are the two sandstone and Harmon Formation.
Is it possible that these were not laid down over millions of years?
Not really.
So then how did this disappear? You just said it just happened to erode. Well, how come it didn't erode everything else?
Or maybe it didn't deposit. I mean, that's also an option.
That's what I'm saying. I'm saying they're not millions of years old. Then I would say that, we can agree on that one then too. And then the big Colorado Plateau, this would be it's about the size of Germany. It'd be about the fifth biggest state. If that was a state, it'd be after Montana. Again, that's a lot of force. That's a lot of area that got pushed up. And you think it was what again?
Wouldn't that be plate tectonics? Is it not?
Well, that's a big picture theory, but the force of it, what causes those plates to move? Why don't you have these
convection currents in the mantle?
Convection currents in the mantle, but are you aware of the crossover depth? Or like 200 miles below the surface, once it gets that dense, it just keeps sinking. It doesn't come back up again.
All right.
How did Red Butte form? 1,000 feet of Mesozoic. What?
I don't know how Red Butte formed. I'm not really familiar with Red Butte.
And I would say this is a remnant from the Great Denudation. Again, that's 1,000 feet of sediment that got sheet eroded off of the size of Vermont. And then the hydroplate theory, these two lakes draining catastrophically logically explains how 1,000 cubic feet, or 1,000 feet over 10,000 square miles, that would be 2,000 cubic miles of sediment got raised off. I would just ask you to consider that. And there's Red Butte again. What crushes basement rock? These are compression cracks in the basement rock of the Grand Canyon. What force would compress granite that much to make it crack?
I think, again, you're not going to like my answer, but I think probably plate tectonics.
Again, and I would respond, what force is moving them with such tremendous force?
Probably the convection currents in the mantle.
Okay. All right. And I would suggest that the hydroplate theory explains this too. When the hydroplates were sliding on supercritical water, it's friction free. And then when they meet resistance, you get them compressing. And that also explains the slanted ones. And this is where all the sediment got washed out there. Okay. And what Walt Brown predicts is when you predict he predicts that the sand from the sand dunes and the Imperial Sand Dunes will have come from the Grand Canyon. That's his prediction. And he also predicts that the inner gorge would be a tension crack. It's going to have a V at the bottom of it. And again, do you have any predictions from your perspective of the past, a blind chance perspective of the past? Do you have any predictions based on that?
About the crack in the basement?
Any prediction? Do you have any prediction at all that we can look at and see if it's confirmed or denied in the future?
Let's see. I'm sure there are some. Mostly I have things like, why can't you find certain things in certain layers? And if you could, that would invalidate everything.
Right, but that's not a prediction. What do you predict? What do you predict to be discovered that would validate a blind chance perspective of the past?
All right, I would predict that you would find soft-bodied animals in Precambrian, and I would predict that you would find things like arthropods in the Cambrian.
Have they found that already?
And that has been found.
Okay, so that's a post addiction. That's saying something after you found it. Is there anything that's unknown that you would say, that you would predict based on a blind chance perspective of the past?
That eventually, well, I don't know. I gave you 2 examples, and they're not really exactly what you're looking for. So I would have to think about it a little harder.
Right. And that's what the hydroplate theory does. It does make predictions. It's got about 50 of them. Fred McNam has documented, he thinks that 20 of them have been confirmed. And that's the sign of a good theory, is if it makes predictions. And he said, Walt Brown says, if you don't make predictions, it's weak science, and it shows a lack of confidence in what you're teaching. And so again, I think that would be one of the neatest exhibits. They could have this do you think that this theory of explaining the Grand Canyon should be presented for people to think about, since their theories don't work? Should this one also be also be presented on the website and at the park?
I mean, I think you can look into how the Grand Canyon formed and everything and present it publicly. But when you start saying, well, it proves the Earth is 600 years old or whatever, I think that's a little bit different.
So if I hear you right, you would agree that multiple theories, including this one, should be presented at the park and on the website.
If you can present it in a way that doesn't say it doesn't totally go against other fields of science.
Well, we don't have to say how old the Earth is. We can just say two huge lakes drained to make this.
Sure, if you can prove those lakes were there and they really did that, yeah, teach it all you want.
Well, they've got theories there that they can't prove. They got four theories that don't work because they can't prove them. Could this theory be presented alongside of them?
I mean, you can teach it at church all you want to, I guess.
So you just want one theory to be taught instead of 2, even though that theory doesn't work.
If you can get some really good evidence together for why the Earth is young and how all
this has nothing to do. This has nothing to do with the age of the Earth. This is the whole
argument about Grand Canyon is kind of about the age of the Earth.
Well, they're claiming that it's millions of years old, and I'm saying that it's not. Okay, they've got one theory that they're teaching as dogma, so people just memorize and conform. I'm saying there should be 2 theories so people could think. Would you support an opportunity for people to think, or would you rather them just see one and memorize?
Well, I don't think anyone should just memorize things. I think you should go out and look for evidence yourself.
Okay, yeah. Well, to think you need to see. You're going to need to see two issues, 2 ways of looking at it. Could this one be presented? Would you want this one to be presented so people could see this perspective?
Well, like I said, if you can get some really conclusive evidence that lake,
it doesn't matter. They don't have conclusive evidence for the 4 theories right now. This one has very compelling evidence.
I can say that I don't have great evidence that the Grand Canyon was carved by a magic unicorn that wears a party hat all the time, but I could teach that.
But
one more question, Brian.
Okay. So if I hear you right, you don't want a theory that can explain the Great Denudation. It can explain why the layers are. It can explain the funnel. It can explain why it's carved into the hard basement rock and a myriad of other features at Grand Canyon. You're opposed to that theory being presented along next to 4 other theories that don't work. Is that accurate?
Sure, we'll go with that.
Okay.
Gentlemen, thank you very much for a fantastic first cross exam of 25 minutes. To the audience, thank you for the engagement and interaction. I appreciate it. I enjoy watching the live chat, seeing what everybody has to say on the issue, both those who agree with Brian and those who would lean to Jackson's position. We got a pretty good mix. So I'm all caught up on your questions, your comments, and your challenges. Those are all saved. Keep those coming in. And Jackson, you now get to lead the way for your 25-minute cross exam starting now. The floor is yours. Right. Go ahead.
All right, let's start with the Bass limestone. So clearly fossils were forming in this pre-flood Would you consider the Bass Limestone as a pre-flood ocean?
No,
No. What would it be?
the limestone formations would be a consequence of the flood. It
Even
got
the
laid
Bass
down.
Limestone,
It got laid down
even,
during the flood.
even below the Great Unconformity.
Well, yeah, those layers that are slanted, those
Mhm.
layers were laid down. Those layers were laid down during the flood, and then during the compression event of the hydroplate theory, the basement rock buckled. Therefore, those layers that were on top of it slanted, and once as it buckled, there were still layers that were still moving pretty fast, and that beveled it off. So I would say that those layers of sedimentary rock are a consequence of Noah's flood, or of
Okay. So
the hydroplate compression event and the flood.
why are there no significant fossils? I mean, we have stromatolites in that part, but we have only. I mean, why is there appears to be an evolutionary progression in the strata? Why is that?
It could be hydraulic sorting. You know, they could have got sorted through liquefaction. That would sort things by shape, dense, and weight, density.
Well, like
Size,
I've showed the.
size, shape, and density. That'll sort out. If you take some mud and sand and clay and you put it in a bottle and you shake it up, it's going to settle out into
Sure.
its size, shape, and density. And that's
But
what could have happened.
why do I find? I've personally found the beaks of cephalopods next to the shells of cephalopods not connected to each other in the same layer. How is hydrologic sorting accounting for that one?
Well, that could be like a fossil graveyard. You know, they could have also been whirling around, you know, and most of the
depending
fossils.
on what happened, that's the explanation to fit, kind of an ad hoc explanation to fit into this worldview. There's no other way.
Well, again, I didn't prepare for this. I was preparing for the Grand Canyon. So
Well, I mean, it's all related to the Grand Canyon.
What's that?
I mean, it's related to the Grand Canyon, the strata of the Earth. That's the Grand Canyon debate.
Okay, but the fossil with the beak and the other thing, where are those located?
Well, those I found in Arkansas, but there are nautiloid fossils in the Grand Canyon.
Yeah, and I would agree. Then some of those nautiloids are standing vertical, and you and I both agree that that was laid down rapidly.
Not
I would say not just that layer, not just that layer of the red wall limestone. I'd say the whole 500 feet of it was laid down rapidly.
All right. So why is there no hafnium-182 anywhere in the world?
I don't know.
You know,
I've never heard of that, and especially I didn't see it when I didn't see that when I was preparing for the Grand Canyon.
All right. Well, let me see if I can find a. Okay. So to form the Grand Canyon, it would take a high energy flow, right, to deposit that sediment.
Yes. Well, a high energy flow to cut the sediment.
What about to deposit the strata there?
Well, that could be a sign of the flood. That could be sorted through liquefaction. You know, that could be a multitude of ways. But I think that millions of years to explain that doesn't work, especially with that rock that's lifted up into it. I think it's time to put that paradigm away, even though that's the New Testament for people that believe in blind chance. They don't want to get rid of it. And yet there's a lot of anomalies that are making it look really bad, especially like
just to clarify, you think the strata was deposited pretty rapidly, right?
Well, it depends. It could have got sorted. You know, it could have got sorted through liquefaction, because back then there'd be huge waves. You know, the tides, there's no continents to break them down. They could be 200 feet high.
Sure, but either way, if you're getting sorted, then that's destroying all the trace fossils. But if it's getting deposited rapidly, that's also destroying all the trace fossils. So why are there footprints? Why are there any trace fossils at all?
Yeah, that's a good point. Yeah, we've got to think about that. And again, I would say that there's trace fossils, and I just looked at Walt's book today. He said that it's going to be muddy water full of sediment, and as the plates are buckling, they may rise slowly out of the water. The animals run to higher ground. Most of the tracks in the Grand Canyon are going in the same direction, and then it comes down, and then the water covers it up gently, and then it preserves them, because we do not see footprints being preserved today. We do not see raindrops being preserved today. There was something special that happened in the past that's not happening today.
You're saying that so you're saying that that's not even really biblical, is it? That these things are rising out of the water. It says that the highest hills were kept. That's what the Bible says.
Well, eventually, yeah. As the flood goes on, it's good. The water's going to continue to rise. And the Bible also says that there was water inside the earth in multiple different places. It says the fountains of the great deep broke up, and we can see where that happened with the mid-oceanic ridge. And it's that's how he came up with the hydroplate theory. Actually, you know,
How are you getting 4 layers stacked on top of each other that have footprints in between the Redwall and Kaibab limestones? So we're in flood strata. It either got sorted out and it would have destroyed those footprints, or it would have laid down at different times, maybe within weeks, but still different times, and you still have sandwiched footprints, and it doesn't make any sense.
Yeah, and that is a complicated issue. And it could be that that's just what was coming out of the, you know, that was what was in the water at that time. Was the limestone or the sandstone. That's what was coming up. And that was what was in the water at that time. And that could possibly be what happened there.
Well, you say the water, how do you explain those mud cracks?
Mud cracks.
Mud cracks. There are mud cracks in the Grand Canyon. There are mud cracks all over flood strata throughout the world.
Well, the cracks would have had to happen after the rock was solidified. And the way you get the sediment for the sedimentary rock is from the hydroplate theory, wearing away the granite and the mantle below. And then the cementing agent was in the water. And so that's how you get the stuff to turn into sedimentary rock. And then eventually, after it was a rock, then it cracked. And, you know, I'm not sure specifically about the mud cracks. I'm not familiar with that term, but that's how
desiccation cracks, mud cracks. But they form when the sediment dries out, cracks.
Yeah.
It's filled in with something else, then it fossilizes that way. And I don't see how that happens in time for them to, I mean, first of all, they're forming in dry land. And then they have to get preserved without being washed away in a flood.
Yeah, and I guess I'm unfamiliar with those, so I really can't speak to that.
All right.
Are there where are they in the Grand Canyon? Oh, I guess no. It's your turn to ask questions.
It's the Mauve limestone.
What's that?
I think the Mauve limestone. I can't remember exactly, but it is in the Grand Canyon somewhere.
Oh, okay. Yeah, they got dinosaur footprints on the Mauve sandstone too.
The sandstone, right? No, they don't. Mauve limestone.
The Mauve. I spoke. It's the Mauve something. You can see this. You can see the footprints today of dinosaurs.
But they're not dinosaurs. That's the Cambrian.
No, these were dinosaurs in the Mauve.
Okay, you're right. I'm thinking of the Tapeats.
I saw them last year.
I don't. I think the Mauve is Cambrian, but I think you might be thinking of the Tapeats, the Coconino.
No, I think it was pretty sure they said it was the Mauve, but I could have heard it wrong, or I might have read it wrong, or maybe I could be remembering wrong too. That's a high possibility too.
All right. So again, we have a similar problem. The trace fossils, but also the ripple marks. We would expect in a high energy environment or in sorting, like you suggest, those would not exist today in flood strata.
Well, unless it gently rose out of the water and got buried rapidly, and then gently came in, and then the water was full of mud that protected it. You know,
I think Noah's Ark would have eventually hit a land berg and sank.
Pardon me?
I think Noah's Ark would have crashed into one of these things eventually, rising up out of the water everywhere.
Well, not if God was with him.
So we're invoking miracles, though.
Well, matter from nothing is a miracle. Life from non-life is a miracle.
No one says it's matter from nothing.
Everybody believes in miracles.
I don't believe in miracles.
Where did matter come from?
I say I don't really know.
It's your turn to ask question. I'm sorry.
I think there's some kind of explanation. So how did the cicadas survive the flood? We have cicadas that they, from 2 to 17 years, the larvae go underground, exist off tree sap on the roots, and they emerge, and the adults of every species lives about 6 weeks. So either they drown in the flood or the adults die without a place to lay their eggs. So why do they still exist?
Well, that's how they survive now. Maybe they're a lot tougher than you're giving them credit for. Maybe they can survive without, maybe they were dormant. Some things go dormant. They can take, they find bacteria in comets and it's dormant. It's still alive. I don't know about the cicadas. I don't know. What's that?
The earth is flooded though. Where would they be dormant?
They could be floating around. Maybe the eggs are just floating around. I mean, insects are pretty good at surviving a flood. After a flood, it's pretty much.
Ants can survive, I think it is 3 days underwater. Bees a similar amount, maybe a week.
Well, there's going to be logs. There's going to be logs floating around too.
But eventually you'd think they'd sink, most of them.
Well, look at Mount St. Helens, Spirit Lake. That was 46 years ago. There's still logs floating there today.
Sure, that's a pretty still little lake and different kind of conditions on that. I mean, a rough ocean, I think eventually most of those logs are going to sink. Maybe a few of them will float through the whole time. But
why would they sink faster in the ocean than in a lake?
Well, you got tons of waves and current messing with them in the ocean.
Yeah, but they're still in the water.
Sure, maybe some of them floated, but I don't know. I think that's. You have to say that for really any arthropod with a short lifespan.
Well, yeah, but I mean, if they can float in Spirit Lake for over 26 years and they'd probably be there for another 26 years. Do you think it's possible that they could float 1 year in the ocean?
Yeah, I'm sure some of them do. I'm sure it's possible, but yeah, I mean, maybe. Now, amber is pretty common in Cretaceous strata. And insects are in that amber. How would the amber get in the Cretaceous strata with insects in it? That's a flood layer.
How would amber do that? Well, the amber would come from the tree resin and it would bury them. And then the flood could bring it wherever they want.
Sure, but the trees are all dead and floating.
Well, they broke off and then they covered as they broke off, the resin flowed and it buried salamanders and insects. My friend just showed me a bunch of them. And and it preserves them really well. And what you'll notice about those things in the amber, they're not transitional.
Well, I've seen spiders with tails in amber, the Burmese amber. Not exactly transitional, but definitely not modern.
Well, it's just a species that went extinct. There's a lot more animals that went extinct.
Well, so you just write it off when it doesn't fit. You just say, well, it's just something that went extinct.
Well, that goes both ways.
Let me ask you this. Is there anything that would really ever change your mind on this subject? And if so, what would it be?
That's a good question.
Mm-hmm.
That's a good question. I'll have to think. Is there anything that would make me change my mind that the Bible's not true, or that the flood didn't happen?
No, the flood never happened. Not necessarily that the Bible isn't true per se, but that the flood didn't happen.
Wow, because I look around and that's all I see is evidence for a flood. Boy. Yeah, that's a good question. I don't know. I mean, there's just so much compelling evidence with the fossils and the layers of rock and the erosion everywhere. There'd have to be even more evidence that it didn't happen, but I don't see it.
But what would that look like to you, do you think?
Well, you couldn't have worldwide layers of sedimentary rock. You couldn't have fossils. You couldn't have.
Well, I'm asking you, what would evidence look like?
Yeah, and I'm telling you what it would be. There would be no evidence of there would be no worldwide layers of sedimentary rock. There would be no fossils buried in these rocks. There would be no footprints preserved. There would be no, huge erosion marks. The world would be way different if there wasn't Noah's flood.
Now there are erosion marks. We've been talking about how there's not really any erosion in the Grand Canyon all this whole time, but now there's erosion.
Well, look at the Grand Canyon itself. Would you call that erosion?
Sure, that's erosion, and the layers have erosion in between them also.
Yeah, not like that. I mean, we're supposed to believe that while those layers are soft, they aren't rock yet. There's no rivers cutting them, and yet once they're hard, then this little Colorado River carves through it. All
Well, that
elements.
kind of begs the question: if all the strata was soft, why didn't all the rivers form huge canyons through them?
Well, they didn't make that. They didn't make Grand Canyons because they didn't have two huge lakes upstream from them. They weren't a mile in the air. They didn't have all
But if
this
they're flowing
potential
through mud, they
energy
kind of
to
cut through
carve
that a
the
little
canyons.
faster, right?
What's that?
If they're floating through mud, you'd think they'd cut through a little more, right?
Well, not if. Well, the Grand Canyon didn't form right after the flood. It's a few hundred years after the flood, because you needed the sides to get hard.
How do you know it was 100 years after the flood?
What's that?
How do you know that? Were you? I
Because,
mean, as we say, were you there? How do we
no, I
know that
wasn't
time
there.
frame?
I wasn't there, but you can see that the Kaibab limestone had to have time to get hard,
I
and you
would
had to
agree it
see.
did.
What's that?
I would agree with that.
And you would have to see that those spires that are in Grand Canyon had to get hard.
Hmm.
Otherwise, because if it was right after the flood, they'd slump in. It'd be a big bowl, not in a big canyon.
That's
And
right. So a few hundred years, all the strata lithified.
pretty much, or they
Or
solidified.
50 years,
They
or
went from
1,000 years. We're not sure.
they went from sediment to sedimentary rock over those
Mhm.
few hundred years.
Now, I can give you a bunch of different dating methods where I can support my worldview. Can you give me a dating method to support that couple of hundred years claim?
Well, the couple hundred years.
Where is that number coming from?
Well, that comes from I think it's the fact that the Kaibab limestone had to be rock, and the fact that the side canyons had to be rock.
So it's not like magnetostratigraphy or radiometric dating or anything like that. It's just because it had to be hard.
Yeah. And those, every dating method has assumptions because they don't know everything. They don't know if the decay rate's been constant for millions or billions of years. They don't know if the initial condition of the rock, if there's any daughter element in it. And they also don't know if it's been contaminated.
Isochron dating doesn't really take into account it doesn't really use as many assumptions as you would say.
Which one doesn't? Which one doesn't?
Isochron. Isochron, it's like plotting a bunch of different ones together, basically.
And that shows millions of years?
They all do, yeah.
How do they test that? How do they know that?
How do they know what? The decay rate?
Well, how do they know it points to millions of years? Because when they tested the lava from Mount St. Helens, they were way off.
Well, like I said, that had just erupted and no daughter product had accumulated.
Well, then they shouldn't have came back with any dates. They should have said non-testable, but they came back with dates.
That's not how a mass spectrometer works. It doesn't say non-testable. It says something with the ratio of the elements. It's not going to say this doesn't make any sense. That's not how they work.
So then, it's okay. But it did give a date for Mount St. Helens.
Sure.
And we know that was wrong. So how do we know that it's well? But then we're supposed to believe that it was right when we don't know the age of the rock. That doesn't seem logical to me.
Well, like I said, they dated Mount Vesuvius, which, a couple thousand years ago erupted, has just enough time to have accumulated some daughter product. And how did they get roughly 79 AD from that if it doesn't work? They know why it didn't work for Mount St. Helens, and they know why it did work for Mount Vesuvius.
But again, they dated other rocks too, like in Hawaii, where it should have been 200 years, and it comes back with hundreds of thousands of years.
Yeah, 200 years isn't very long. That's not long enough for potassium argon.
Well, right, but they still come back with those wrong dates.
Sure, they do, but that's because they're wrong, and because they don't have enough daughter product in the sample.
So then why do they tell people it's that old?
Because the mass spectrometer doesn't just say error. That's not how the reading comes out.
Okay, well, from my perspective, that's a very unreliable test. If you know the date of the rock and it gives you wrong answers, it doesn't make sense, in my opinion, that you're going to believe the same test to date a rock that we don't know. That's my opinion.
All right, what else do we have here? Pollen grains. This is a good one. And they found pollen in strata in the Grand Canyon, I believe. But you find spores in the Devonian period. You find conifer pollen in the late Carboniferous. You don't find angiosperm pollen until the Cretaceous. Now, how are these getting ordered like this?
Now, again, I was studying for the Grand Canyon debate, and I wasn't going into fossils, so I'm not equipped to speak on that.
Well, there's tons of fossils in the Grand Canyon. I mean, I didn't mean to catch you off guard, but that's.
Well, this was the formation of Grand Canyon. We should be talking about mechanisms of how it formed, not how fossils got there. Because
in my mind, whether it formed, it's like the old creationist argument about Niagara Falls. They used to say Niagara Falls is eroding too fast. The Earth can't be young. The Earth can't be old. But if you just realize that Niagara Falls didn't exist the whole time as Earth, that argument doesn't make any sense. So in my mind, it's the same thing. It's like whether or not the Grand Canyon formed in 1,000 years, 2 weeks, or 7 million years, the Earth is still old.
I would disagree.
All right. Well, I think I'm pretty much. Let's see. I think I'm pretty much good on that. We can go to the next topic if you guys want.
You have 4 minutes left, so it's totally up to you. You can utilize the 4 minutes in more of a free-flowing discussion, or we can move into closing statements.
No, we can just do closing statement. We can just do that.
Okay, gentlemen, I got to say that was an excellent cross exam. Lots of points discussed. In a way, it appears like we left no stone unturned on the Grand Canyon. So to the audience, I am all caught up on your questions, your challenges, some additional arguments that came in. If we could, we have 10 more minutes until we engage your questions, as we have 5 minutes each for closing statements. So please, if you have something specific on the Grand Canyon or some pushback on anything that Brian and Jackson have said, please send those in, and that way we can make the debate that much more comprehensive, which is what I love about the audience Q&A periods. In many ways, these debates can be free peer review for the debaters. So, okay, as you got Jackson that's holding Brian's feet to the fire, Brian's holding Jackson's feet to the fire. I love it. It helps us to refine our arguments. I mean, you've heard it said that you might feel confident in your position and you know what you're talking about until you're cross-examined and your feet are held to the fire. So this is great, gentlemen. Brian, I see your slides being shared. So 5-minute closing statements. Let me get everything ready here. I'll get your slides up. Okay. 5 to 6 minutes. I don't want you guys to feel rushed because I think it's a good opportunity to bring everything home essentially and wrap up our thoughts. So Brian, the floor is yours. Go ahead.
All right. Well, thank you so much for doing this. And when Grand Canyon gets brought up, this should be the first question that anybody asks. If the river cut the canyon, what cut the side canyon? Because they're just as deep and it doesn't have a river. And then also, why did the river cut through the plateau instead of flowing around it? And why did the river cut down into the hard crystalline rock of the inner gorge instead of getting wider like it should have into the softer sedimentary rock? And to answer all these questions, again, Grand Canyon is bulging and cracking 3 times. You got 2 huge lakes a mile in the air with tremendous potential energy. Grand Lake starts cutting between Vermilion Cliffs, and it cuts this funnel, goes down to the hard Kaibab limestone. It couldn't go any deeper, so it spreads out and makes this funnel that's 18 miles long and 12 miles wide. So that's a lot of sediment that's missing. So then that Kaibab limestone bulges and cracks, and then the water cuts through the crack and undercuts Hopi Lake. And so now you got 2 lakes that are catastrophically draining. This is how you get the great denudation. It's sheet eroding everything off of the Kaibab limestone, except for Cedar Mountain and Red Butte and a bunch of other places that are remnants of this. So then the Kaibab, and not only the Kaibab limestone bulges, but that whole area, the Kaibab Plateau, bulges and cracks. And then the water cuts through that crack, and it's cutting below the water table. So then you got water coming in from the side, which is bringing sediment with it. And that's why you get the side canyons. And then it cuts all the way down to the hard basement rock of the Grand Canyon. And there's nothing pushing down on it. So that rock bulges and cracks. And that's how you get the inner gorge. That's bulging and cracking 3 times. And contrary to what Jackson thinks, Thomas Chamberlain, he says that there should always be multiple working hypotheses. Otherwise, people will just memorize and conform instead of think critically. And my position is people should be able to think. They should be able to look at different theories and come to their own conclusion. And then again, the best place to do this is on page 247 of creationsciencecenter.org. Look at all the theories, look at all the features, and come to your own conclusion. Don't believe it just because I say so, but look at it and think about it and come to your own conclusion. You know, go into Real Science Radio, rsr.org, and listen to Grand Canyon Month, and Walt Brown and Brian Nichol talk about how it couldn't have been millions of years and it couldn't have been the river, and other resources that I highly recommend. Number 3 there, Mission Imperative. That's Mike Snavely. Get this DVD. It's Grand Canyon Puzzle on the Plateau. That's a good intro to the Grand Canyon. And he talks about all those features of like Zion and Bryce that are part of Grand Lake. And then for your PhD in the Grand Canyon, go to Brian Nichol on YouTube, The Origin of Grand Canyon. Very well done, very well documented. A lot of the information, a lot of the slides are thanks to him. Then also is Genesis History, Mountains After the Flood. You're going to see that those layers bent while they were still soft because they didn't become metamorphic. And that's excellent. Oh, and then also go on creation trips. You know, go on to Grand Canyon trips. You know, Creation Today had one. I went on it last year. It was great. You fly into Phoenix on Thursday, and then on Friday, you're on the river. And then on Saturday or Friday, you're on the rim. Saturday, you're on the river. And it's so much fun. And then Sunday, I spoke at a church. And then I was on my way back home. So again, and then Starting Point Project, they have one real similar. Plus, you get to go to Antelope Canyon. And then Mission Imperative has an 11-day safari going through all those different features, and he explains it perfectly with the hydroplate theory. Okay, so what do we do with all this information? Well, let's get it out there. This is your assignment. If you're convinced, or even if you're not convinced, if you want people to have an opportunity to think, go into National Park Service, nps.gov, go into Grand Canyon, and then you click Learn About the Park, go down to Nature, and then go over to Geology and click that button. Scroll all the way down to the bottom. You're going to see 4 theories that don't work, and it says, we will continue to learn. Well, let's give them something to learn, because at the bottom of the page, it says, was this page helpful? And I put no. I said, since none of the hypotheses work to explain Grand Canyon, please add the hydroplate theory's explanation. It logically explains many features, and see the hydroplate, see Brian Nichols' channel. So I encourage everybody to go onto this website, let them know their theories are a bunch of garbage. We want to see a theory that works, because this has happened before. They've taken out the Specimen Ridge plaque at what's that place? Yellowstone. So if enough people point it out, it could change. And we just want an opportunity to think. And then you go up to this one, Grand Canyon Geologic Formations. Scroll all the way down to the bottom, and there's that sentence that they hide really well, saying that they don't know how the Grand Canyon, how the river started, and they still awaits a clear answer. And then, was this page helpful? And you click no. And then you say, that's a false statement. There is a clear answer. You know, the hydroplate theory logically explains the origin of Grand Canyon and the resulting river. See Brian Nichols' YouTube channel. So I encourage everybody to do that and get more and more informed. And basically, we just want people to think. You know, Walt Brown, he says, widespread belief systems seldom change when frequently reinforced by influential institutions. Yeah, they seldom change when you're not allowed to think about anything else. Okay, and then he says, but when vast numbers of people realize they've been misled, an intellectual revolution begins.
30 seconds.
And that's what's happening. We've been misled. This Grand Canyon did not take millions of years. They should put other theories up there so people can think, and then take a look and see who steps up to the microphone. And I do thank Jackson for stepping up to the microphone. It's rather rare. So again, when this comes up again, if the river cut the canyon, what cut the side canyons? And why did it flow through the plateau instead of around it? And why did it cut down into the hard rock instead of wider? And so that's bulging and cracking 3 times. And this is how you get to help make a difference. Just go in there and put a comment in there. Say you want to think. You just don't want to memorize.
Brian, thank you very much for that 5 to 6 minute closing statement. Jackson, we'll reset the timer. The floor is yours. Go ahead.
All right. Well, I agree with Brian. You shouldn't just blindly believe things that you're told. I think you should get out in the field, do fossil hunting yourself, look at geology yourself. And I think when you do that, and especially I look for microfossils most of all. I got a microscope right next to me. I got tons of limestone dissolving over here. When you look at that, it's I mean, the macro fossil record is pretty convincing, but when you look at the stuff you find under the microscope, I just don't see a way that a flood explains it. I don't see the formation process of Grand Canyon is all that important to the age of the Earth debate or the creation evolution debate itself. I really don't understand why creationists hyperfixate on this one canyon. I want them to hyperfixate on the fossils in the side of the canyon and the strata. Excuse this huge poison ivy mark on my head, which I'm just seeing very clearly now that I'm full screen. Yeah, but yeah, get out and do your own research. Don't just believe things you're told. I agree with that. I don't really have much to say. Just the debate stands or falls for either of us at however you split it, whatever. It stands for itself. So thanks, Brian, for doing this. Thanks, Donnie, for hosting it. And it was fun. And I guess let's get into some questions.
Jackson, thank you very much for that closing statement, short and sweet. Okay, that wraps up opening statements, rebuttal, an excellent, very enjoyable cross-examination. I could have even listened to that for longer. Very good. A very interesting topic for sure, the Grand Canyon. And that's what we like to do here on Stand for Truth, is not only debate general creation versus evolution topics. We do like to pick a single topic and just dedicate as much time as we can to it, like we did here tonight on the question, what best explains the Grand Canyon? So excellent job, gentlemen. Let's get into some of these questions, and that way we can expand even more on the topic. Question for Jackson Rowe comes in from Pauline. How does a tree go through layers? Speaking of polystrate trees going through multiple layers in certain areas on the planet, Nova Scotia is a big one, I believe, that took millions of years to form. Jackson, what are your thoughts?
Well, the interesting thing about those pictures from Nova Scotia that everyone always uses, they're lycopsid trees. That's Carboniferous strata. Yeah, it's a very rapid deposition in a fluvial deposit. That's a fluvial deposit. It's from a river. But why do you not find oak trees, pine trees, modern angiosperms, or anything along with those lycopsid trees? That's kind of a counter argument. So no, it didn't take millions of years to form in that specific area. Creationists go on and on about uniformitarianism. Geologists accept that catastrophes do happen. They just don't think the entire thing was a catastrophe. So that's my answer to that.
Just for a clarification before we hand it to Brian, and then Brian will get your thoughts. So are you saying in that particular scenario or instance in Nova Scotia, let's say, those layers where those particular trees are running through multiple layers within what you call the Carboniferous era, you are saying in that instance, those layers, though, were rapidly deposited?
Well, in that area, that's a fluvial deposit. That's clearly one continuous layer, even though it's thick, with trees through it. So yeah, that's what I'm saying.
So you're saying in some instances where you have multiple or large pockets of strata, you would say all that strata could be laid down quickly to explain those trees, why they didn't rot and fall over.
Well, if you can find a tree poking through the Permian Triassic boundary, I'll be like, yeah, that's a good point. But I don't think you can.
But I'm saying in that particular instance, I understand you're calling that big giant group of layers there the Carboniferous era. Yeah. But you're saying all of that you find these trees going through, the polystrate trees, you would say from your position that is just an example of like a local region that was deposited rapidly?
Yeah, that's
fluvial sediments, like you said.
It's all Carboniferous strata. It's not poking into the Permian right there.
But it's not just one thin layer of strata. So I'm saying, according to your,
very thin, it's a thick layer. Yes.
But that thick layer was all laid down quickly rather than over millions of years in your position.
Could have been hundreds of years. It would have been pretty rapidly. Yes.
Okay. And that's the clarification. Okay. Brian, over to you.
I would say hundreds of years would be too quick. I mean, it's going to rot in hundreds of years. It has to be a lot quicker than that if it's going to
quicker. Yeah.
Yeah, it has to be a lot fast. I'd say it has to be. I mean, it's got to get buried quickly, And they found fossil trees that connect two coal seams in Tennessee. And those coal seams are supposed to be tens of thousands of years different. And again, it's like, okay, we find the trees there. So that layer was laid down quickly, but the other layers couldn't have been because there's no trees. I'd like to see, I think Bob Enyart wanted to do that. He wanted to get a map of where these polystrate fossils were and see if you could connect all these layers together based on different polystrate fossils. But yeah, I think I don't know. To me, that's a strong argument for a flood.
And what about, to maybe expand on that even more, Jackson, what about somebody who might point to other because we say polystrate trees, but there are other fossils, including organic life, that go through more than just one layer. How would you respond to that? Would you also say those layers are examples of rapidly deposited strata?
They're not going through, like, they're not poking through the Jurassic into the Cretaceous. I mean, a school of jellyfish, I've never seen that example. I don't know what he's speaking of there, but I know that Nova Scotia polystrate trees.
How, maybe this will help the audience, how big of a tree would it have to be to, according to your standard, pop into other so-called eras, like the Carboniferous, Ordovician, Pennsylvania? Because it sounds like you want to see a tree just going through all these different eras.
Sure. Well, you can find one at the top of the strata, but like the Atoka Formation, which is what I'm sitting on, is thousands of feet thick, and it's all Carboniferous. It's one formation of the Carboniferous. It didn't all form at once, but it's one formation.
Now, we'll hand it to Brian because it is an interesting topic. From my understanding, there's thousands to tens of thousands of polystrate trees around the world. Joggins, Nova Scotia is one area. There's many others. So whereas someone who holds to a worldwide flood would say, okay, thousands to 10,000 of polystrate trees, that's just the trees, and then you can include other fossils as well, globally in different regions. A young Earth creationist could extrapolate that to mean, okay, a worldwide occurrence here. But if you just saw it maybe in a couple local areas, then okay, maybe a local flood or local catastrophe. But because you find tens of thousands worldwide, in your opinion, why can't that be extrapolated to mean a worldwide event caused that?
Well, if you look at the polystrate plants, and it's Calamites too sometimes, it all tends to happen in the Carboniferous, and there a lot of peat bogs existed in the Carboniferous, a lot of anaerobic environments. So I think one of the explanations is they're standing up in these peat bogs and being preserved that way, like the coal seam you mentioned.
Brian, any thoughts there?
Yeah, these jellyfish, I think they were in a gravel or in Wisconsin, and they were in like 7 different layers. So these jellyfish, you think they went back there every millions of years to that same spot to get fossilized? And I think that a worldwide flood can explain how you get fossil jellyfish. And I think millions of years has a real hard time explaining any fossil, really. I think that fossils have to be laid down, have to be buried rapidly if they want to form. And then with the petrified trees, you look at these, the ones on Specimen Ridge at Yellowstone, they don't have any roots. They didn't grow there. They were transported there. And yet there was a placard that used to say there was tens of thousands of years for a forest to grow and die and forest and grow to die. They had all these different layers of forest that they thought grew separately. And then they pointed out they don't have roots. They didn't grow there. So then Grand Canyon, to their credit, they took that sign down. And what I'm hoping to do, and you say we hyperfixate on the Grand Canyon, or they took it down at Yellowstone, and you say we hyperfixate on the Grand Canyon. It's like, well, if it's wrong, it's wrong. I don't want them to take my tax money to teach something that's false. And they got 4 theories that don't work. There should be another theory that people should look at that can be a little more compelling.
Thank you, Brian. Jackson, question was for you. So if you'd like to, you can have the last word.
I was going to say something, but to be honest with you, I lost my train of thought. We can just go to the next question.
Okay. Appreciate the engagement, gentlemen. Let's move to the next question here that comes in from Why Budry. Jackson, clay inside volcanic ash is a major catalyst for fossil formation. A bunch of trees in Spirit Lake were found fossilized just 2 years after Mount St. Helens. What are your thoughts, Jackson?
Well, again, I don't know that explanation, but I've found subfossils, like I mentioned in my opening, Corellia shells from Kauai. So fossils from what I've seen form very slowly. So I don't know about that example, but
Brian, over to you.
Yeah, that is interesting. Spirit Lake is a good test lab. It shows those things floating around and then sinking to the bottom and then getting covered with sediment, just like at Specimen Ridge. And speaking of fossil petrified wood, I got this from Arizona, and this I got this from Mississippi. This one has a lot of color in it. This one doesn't. I think this one was buried in mud and turned a petrified tree. I think this one was floating around in Hopi Lake. And then the silica in the water, when it cooled off, it had to get out of there, and then it went into the wood. And that's why you got different colors in here. And so again, one is buried in water, or one is buried in mud, and one is formed in water. And I think that that's a rather good explanation for the petrified forest, which it would be in the southeast corner of Hopi Lake.
Thank you, Brian. Jackson, back to you.
I don't really have too much else to add on that. Other than the Corellia shells subfossil example, but that's all.
For a follow-up and clarification, how would you respond then in light of this piece of evidence here? A bunch of trees in Spirit Lake were found fossilized just 2 years after Mount St. Helens. Mount St. Helens erupted in observable time recently and formed many features that one might assume if they didn't see form would take millions of years. You got the polystrate fossils as well. You argue found in Carboniferous strata, which my understanding, Jackson, correct me if I'm wrong, go through about what you would say is 60 million years worth of time.
Something like that, 300 million years ago, roughly. But
right, but then for about 60 million.
Mm-hmm.
So what if a creationist were to say, okay, these examples plus others, but maybe focus on these two, show that these features, it's not necessarily about time, but a process. So, the debate, deep time versus catastrophe. Okay. How would you respond to that? Not necessarily time, but a process.
Well, I don't know, again, this example, but I would suspect they're not actually even fossilized after 2 years. But I can't say that definitively, but I suspect it strongly.
Okay. Brian, anything you want to add before we move on?
Yeah, they've been able to petrify trees in a laboratory in like 30 minutes or something like that by injecting silica into it. So if the conditions were right, if the water was rich in silica, and Walt Brown explains why it would be, I could see how these trees could petrify.
I just Googled it real quick. I mean, we can't always believe what the answer is, but it does say, yes, Mount St. Helens has buried fossilized trees. But then it does say they're not the ancient stone-like petrified wood found in places like Yellowstone, but it does say that there are fossilized trees. So that's, interesting there.
Fossilized in a sense, then, I guess, but not really.
Well, okay. Interesting back and forth. I appreciate it, gentlemen. Mike, thank you very much. He's wondering, and I think this is for you, Brian. This is a popular one for sure. And he's wondering about the daughter elements present in Z-pinch. So I guess in a way this goes back to, there's a whole portion between your debate where you guys were discussing dating methods and isochron and getting in deep. So he's wondering about the Z-pinch experiments showing initial conditions. No question from the audience came in on this. So Mike, you're good. Any thoughts, Brian?
Yeah, the Z-pinch, that's very interesting. That has to do with the hydroplate theory, because he thinks that the radioactivity formed during the flood, and he figures it happened because granite is 27% quartz, and when you compress or stretch granite, it sparks. And then he thinks that when they were fluttering, they were crushing together, and they Z-pinched, basically, like lightning in the granite, and it made these heavy elements that could be radioactive. And that's a very compelling case, because if radioactivity came from outer space, it should be all through the earth, and it's not. It's mainly mainly near granite, and it's on the continents. And so it's a compelling case in that Z-pinch. That's the brand new chapter on in his 9th edition. Talking about the origin of radioactivity, which goes along with the origin of limestone and comets and asteroids and Grand Canyon. And it's a very compelling book, and I encourage people to get it. Give it out for gifts. And it's at creationsciencecenter.org. Hopefully the hard print is coming, but you can see it for free. Just go there and check it out, get all the information, and think.
Thank you, Brian. Jackson, floor is yours.
Well, I think we're talking about radiometric decay rates. If they've changed over time, that kind of doesn't go with the strong nuclear force as a force, and it kind of presents some problems for the speed of light, so relativity also. I mean, kind of the whole universe is flying apart at the subatomic level. If suddenly the decay rates are different during the flood, or they suddenly appear during the flood, and it doesn't make sense to me.
Brian, anything you'd like to add?
Well, we're looking at the processes today. You know, if you drained your oil and you took it all out and then you went back, you didn't put the plug in, but you went back the next day and there was one drop that came out every 2 hours, you would say, man, it took, 4 million years for this bucket to fill up, and it would be wrong. We just don't know what happened in the past. We are assuming that what's happening today happened in the past, but that can be a bad assumption.
Jackson, a follow-up question. How would you...
Well, I want to say something to that.
Yeah. Go ahead.
If you fill the car with oil at a different rate, though, the car is not going to explode. It's the difference.
No, I'm talking you drained the oil. It's just dripping
Either
from
way.
the pan.
Yeah.
It's
Well,
just
you drain
dripping.
it at a different rate.
It's just dripping from the pan.
Mhm.
And we're looking at this drip right now and think it's always been that way. But no, there could have been a big catastrophe, which did it all at once. And we're just seeing the remnant of it now. I'm just saying
the drip is not going to adversely affect the very structure of the car.
No, not at all.
Yeah.
Not at all. But we're using that to determine how long it took for the pan to fill up with oil. And it's a bad assumption. And I think we're doing the same thing. I think we're doing the same thing with dating rocks.
How would you, maybe for a layperson, from your uniformitarian or actualist position, Jackson, as a follow-up or clarifying question, from my understanding, the Z-pinch experiments at the Proton 21 lab, they rapidly produced a wide spectrum of daughter elements and super heavy nuclei. So from a creationist perspective, that might make sense. But from a deep time viewpoint, how would you respond to an experiment like that?
Well, I mean, if you're just doing it for one decay chain, I mean, the fact that all of the decay chains can line up for a sample kind of doesn't make sense for that in my mind.
But could it give a perspective of the initial conditions during creation week, or how God may have created the original rocks with a mix of parent-daughter isotopes, or how these processes could take place during the flood? I mean, do they in any way go against, do you think, or contradict a little bit of the uniformitarian assumptions?
We're talking about a scenario where God makes it look old for no reason. I don't know. Why is he doing that?
Brian, any thoughts?
I don't think he made it look old. I think he makes it look catastrophically destroyed. He's making the world look destroyed, and he's left evidence. He's left the fossils and the layers of rock and the coal and the oil, all that stuff. And it's not old, it's destroyed. That's how I look at it. The world's been flooded.
Jackson, how would you respond to somebody like your good friend, Dr. Dino, who you've debated so many times, who might point out something like every speck of dirt, every atom is the same age? That's not the debate. It has to do with the question as to when those layers were formed, essentially rapidly or over deep time, millions of years processes. Would you agree with that? How would you interact with that point?
Well, like I've said before, they're measuring isotopic ratios of decay. Sure, you could say that material has been there, but it's changing into a different isotope or along a different element altogether. I mean, he's sort of right, but he's not actually right. It's just kind of confusing the way he says it.
Well, would it be akin to the atoms that make up our bodies, Brian, myself, and you? They're all the same age, but one of us is younger than the other, so our age is different. Is that how you would explain the rock strata basically?
Are you asking me that?
Yeah, Jackson.
Oh, sorry. I guess I really I thought you were talking to Brian.
Another illustration of all the atoms that make up the material to build a house, same age.
Mm-hmm.
But then at what point in time were those materials actually taken to form and design and build a house? That house, the material might be the same age, but when was the house actually formed? Is that basically what you're saying?
Here's an example from metamorphic rock. They can sometimes date the event of a metamorphosis. Like that rock already existed, but here it went through a metamorphosis event, a heating, and here it is now. Like here's the material. Now the house is built. That's kind of a similar.
Yeah, so it does seem akin. So the question is, was the house built rapidly or over, many years? The rock strata. So I understand with what you're saying, with the mixture of isotopes and the formation of certain features, igneous rocks, so on and so forth, from volcanic eruptions. Mm-hmm. Brian might argue that, well, these were formed rapidly. And you would say, well, no, they were formed. So the atoms, the materials that make up for it, make it up. It's the same age. But how quickly or slowly were they actually laid down is the debate. Would you agree with that? How would you address that, I guess?
I mean, sure, some of the layers are laid down faster than others. I mean, I'll say that. I mean, I don't really know where to go with that one, honestly.
Okay. Brian, and anything you want to add there before we move on?
Yeah, it kind of makes me think of, where did all the sediment come from? The Grand Canyon's full of sedimentary rock. Where did the sediment come from? And how did it get so evenly mixed with a cementing agent? How did that happen? That's what it makes me think of.
Thank you, Brian. And you will, Jackson, let's give you the final word.
Well, this is one of my favorite answers. It came from erosion.
Well, erosion doesn't stick it together. Erosion breaks things apart.
Well, it breaks a bunch of things apart, and they mix together sometimes.
Yeah, but how did it turn into rock? It had to be mixed with a cementing agent. Where did the cementing agent come? Because it's all through the world. Those layers are rock. So something had to mix it really well.
Rock does form in water.
What's that?
Sedimentary rock does form in water after all. But I mean,
right. Okay. Because I've been at a lot of water, a lot of mouths of rivers and stuff, and it's mud. It's not rock down there. It has to be something special. It has to be something special. Like rain isn't turning the soil into rock.
No, it's not.
The sand dunes are not turning into rock. So how did sandstone form? How did sand get mixed with a cementing agent to turn into sandstone all over the world?
Well, rock doesn't form overnight. I can mix a barrel of mud up. It's not going to turn into rock in my lifetime.
Well,
it needs to dry out a bit hard, but it's not going to it's not going to lithify, So I guess we're sort of in agreement, kind of. But
a little bit of agreement, kind of a little bit of agreement. Okay, this comes in from Scriptures and Stones. Question for Brian, I believe. Plate tectonics predicts ancient failed rifts like the MCR, which is deeper than the Grand Canyon. Hydroplate does not. Has Brian heard of an HPT explanation of the MCR? For anybody who might not know what the MCR is, it is
the mid-something rift?
Mid-continent rift system.
Mid-continent rift system.
Apparently, it stretches over 3,000 kilometers across Central America. It's a prominent geological structure. Various ideas as to how it was formed. It's a basin between dipping faults, contains basaltic volcanic rocks. So I guess, to reiterate, how might the hydroplate theory explain such a feature, Brian?
Well, my guess, I haven't heard of it, but does it run north and south?
I don't know.
Okay. Yeah, because
Jackson,
I'm not sure which way it runs.
Because my guess is that could have sunk in, during the compression ridge event. I don't know exactly what he's talking about, but during the compression event, the North America and South America are sliding to the west, and they keep going until they meet resistance and they buckle up. And there could be some places that buckle down too. So I guess I'll have to look into that a little more. But my guess is it runs north-south. That would be my guess.
It says, instead of a simple north to south line, the MCR, Mid-Continent Rift, forms a massive curving U-shaped or branching pattern, sometimes compared to an upside down Y. I'm not sure if that helps. So are you saying that this could have been formed when the fountains of the Great Deep broke open and the continents began sliding apart, some of the effects there?
Yeah, that would be my guess. I haven't looked into it, but the continents were sliding to the west, and North America slid over the mid-oceanic ridge. That's why the Rockies are twice as big as the Andes. And I would guess that other features formed like that. And they might be. It might even be parallel to the mid-oceanic ridge. Like the Rocky Mountains and the Andes, they're parallel to the mid-Atlantic ridge. And my guess would be that might be true too. I don't know. I'm just guessing. I'm making a prediction. I could be wrong.
That's good. Making predictions. As a follow-up, then we'll hand it to you, Jackson. To be fair, I was asking you follow-up questions, Jackson, so I'll do the same thing with Brian. One might argue that the friction and the heat and the energy produced from continents or plates moving apart from each other quickly, rapid plate movements, it would create too much heat, and therefore would just melt the crust and therefore preclude the flood. How would you respond to that?
Me or Jackson?
Brian. You, Brian.
Well, it did make heat. I mean, look at all that lava. Look at all that lava in Yellowstone. And look at all the volcanoes in the Pacific Ocean. I think it did make heat, but I don't think it was. It apparently it didn't. Destroy the Earth. And the sliding. Yeah, there'd be a lot of friction, and that'd be the force that would crush the basement rock of the Grand Canyon. That would also be the force that crushed granite in the Gunnison River, or the Black Canyon of the Gunnison River. That's the force that crushed granite for 50 miles. That's a big force. And and that's why you get all that lava, all that lava under the Rockies that are squeezing out to the side, which forces the Colorado Plateau to rise up. And you'll see those same features at the Himalayas and at the Cascades. I mean, most major mountains have a plateau next to it, and that would be because of that melted mantle, melted granite, the magma.
Thank you, Brian. Jackson, anything you'd like to add?
It's not really a question catered to me. I don't really have much to add to it. Okay.
Let's move to the next question here then. This came in from Alodrossophilia, but then a couple of her questions she had said were answered in the discussion. So I can't remember which one though. So if you have to reiterate, that's okay. Brian, a canyon couldn't be formed through a flood. Well, I guess you said it's post-flood, so maybe that's why she said disregard it. But let's see here. It specifically requires the force of water over millions of years to move the amount of earth in a layer. Feel free to reiterate the basics of your model, Brian, and engage the question.
Okay, well, I would say a canyon could be formed during a flood. A canyon is formed when there's a big force, a lot of water, and I submit that it's moving rapidly, cutting below the water table so that the side canyons form as the water gushes in from the side. And then a lot of it is in a bit, and it all went down to a flood plain, 100 miles on either side of that Colorado River. If it was cut over millions of years, that delta would be like the Mississippi. It would be nice and flat and have all those branching tributaries going out, but it's not. It came down with so much force, it just went right out into the Gulf of California. And let's say it requires the force of water over millions of years to move the amount of earth in a layer. No, I would say that millions of years are not going to move it all over the earth. We don't see any layer being laid down continent wide, much less worldwide. So I would suggest that strongly points to a worldwide flood, because there's worldwide layers of sedimentary rock full of billions of dead things that turned into fossils. And my question today is, where is that happening today? What process is laying down worldwide layers of sedimentary rock? We just don't see it.
Thank you, Brian. Jackson, over to you.
Well, I don't know if you guys are familiar with Waimea Canyon on Kauai, but it formed from an initial caldera collapse and then slow erosion from the Waimea River. Now, the only thing is, you could say that happened all from the caldera collapse, but there's just not enough area, not enough volume in the highlands there to account for the depth and the amount of material removed from Waimea Canyon. It might have carved out the initial channel, but then the only explanation would be slow erosion from the Waimea River over hundreds of thousands of years. That's really all I have to add. It's not really totally related to the question. But
Brian, anything you'd like to add?
Well, it makes me think of Xerxes, which is an island off of Iceland, and it's got features that people think took tens of thousands of years, rounded boulders, all this stuff, sandy beaches, and yet it was formed in 1963, I believe, and we know that because we saw it form, so that looks really old. If we didn't see it form, we'd think it was really old based on the features. And that's like at Mount St. Helens too. You had Engineers Canyon, which got carved out within a year because they were draining the lake. They didn't want it to catastrophically drain. And then you had, the little Grand Canyon of the Tuttle River, which got formed in 8 hours. A big mud flow went through there, and there's the Little River. And that's just like the Grand Canyon, the Little River, then you say, oh, look at the Little River, cut the big canyon. It's like, no, it didn't. It happened in 8 hours. We saw it. So if we saw a canyon 1,000 feet across, 140 feet deep, form in 8 hours, I'm suggesting that's what happened at the Grand Canyon too. It happened very rapidly. And the canyon formed the river, just like the Tuttle River is formed by the Little Grand Canyon of the Tuttle River.
Thank you, Brian. Jackson, you did respond, right? So Brian gets the last word there.
Yeah.
Next question here comes in from, let me see. Scriptures and Stones. Has Brian ever heard of the Bida-Hochi Basin spillover hypothesis?
No.
Okay. What about you, Jackson? Have you heard of
I
it?
have not either. So I don't really have anything to say either on that.
No worries. At least we got it in there.
Mm-hmm.
Brian, why Budgie? A fossil boot print of Australia Army searching for Amelia Earhart during World War II was found on one island. When a Earhart hunter team went back to retrace the steps of that patrol. You have any thoughts on that?
Yeah, I'd like to see that. I haven't heard about that, but yeah, I'd like to see that. That would be interesting.
Jackson, any thoughts?
I mean, it's definitely an anecdote, but I've never heard of that either.
Brian, if you're using this hydrological model, how would you explain liquid water of shouldn't the intense heat evaporate all water?
The hydroplate theory has supercritical water below the plates, which are 60 miles thick, or at the most, well, at least 60 miles. And then it's supercritical, and that means it's under tremendous, it becomes supercritical when it's under at 705 degrees and 3,200 PSI. And he says that eventually it got to be so much pressure, it was 372,000 PSI. And that's a tremendous force. So then when it cracked, it's just going to explode out of there. It's just going to expand like crazy. And when things expand, they cool off. It's the Joule-Thomson effect. And so a lot of that heat would have been dissipated as it expanded. So that's one way of answering how it's not going to boil the Earth. And a lot of the stuff just shot right up into outer space, and a lot of it went up in outer space and got cold and came down and buried the mammoths in muddy hail. That's how you get a mammoth frozen standing up. But yeah, there's different ways to talk about the heat problem. And Brian Nickel does a really good job with that on Real Science Radio, rsr.org. I think they had 2 or 3 shows on objections to the hydroplate theory, and the heat was one of them.
Thank you, Brian. Jackson, anything you'd like to add?
It sounds like we're replacing extreme heat with extreme pressure, to me.
Brian?
Well, it was extremely hot underneath the earth, and then it expanded, and then it cooled off.
Rest in peace, dolphins.
Gentlemen, I got to say, that was a great debate, highly informative, helpful. The Q&A helped me understand a little bit better of where you're both coming from. I appreciate you guys being good sports, allowing the clarifying questions, and engaging the audience. So I think this was an edifying debate, and the kind of debate you'll want to watch a second time for sure, just to absorb and digest all the information presented on both sides. So, okay, I appreciate it, Brian and Jackson, the time that you put in, the work clearly that you put into understanding the topic to come in here and give us a debate that feels informed, as in you both know what you're talking about. So I thank you for that. Also, I thank you for the time that you've given for the debate. Let's get some final words, final thoughts before we wrap it up. Brian, thanks again. Over to you.
Yeah, and my big thing, I just want people to have an opportunity to think. And you need to see alternative ideas if you want to think. And hopefully people go into that website and start asking to have the hydroplate put up next to the 4 theories that don't work so we can think. You know, that's my main thing. You know, give us multiple theories so we can think instead of just ramming a blind chance perspective down our throat at taxpayer expense. That's what really bothers me. So again, I encourage people to go into that website and start asking, and then start getting more informed. And then there's another way to look at everything. You got a creation perspective of the past and a blind chance perspective of the past. And to think that like this house got put together by chance would be pretty absurd. But if that's all we ever see, we just memorize and conform, you know. So I think that and we're supposed to think that our bodies got together by chance, you know, which our bodies are way more complex than a building. So again, we just want people to start asking questions, start you know, seeing both perspectives. And then as far as the Grand Canyon debate, I think the hydroplate theory explains all those features perfectly. And I think that it should be given a voice at the park and on the website and in the textbooks. You know, their theories don't work, and they admit it.
Brian, thank you very much. We definitely uphold the importance of critical thinking here and getting out of our scientific or theological echo chambers, depending on what the debate is important. You both tonight, 2 professionals, demonstrated the importance of it as you guys went back and forth and engaged each other's positions, contrary positions. And this was great also for myself and the audience. We're always learning from these debates, that's for sure. Jackson, appreciate you doing this as well. I said it at the beginning, I'll say it again. I respect anybody who's willing to go outside their comfort zone or echo chamber in many ways, come into the debate coliseum and engage these important issues. Jackson, over to you. Thanks for doing this.
Yeah, thank you guys for doing this. I always like doing these because it always makes me research fossils and geology more, and it gets me, you know, I probably wouldn't have been as into fossils as I became if I hadn't started doing this. I think I started doing this like 2021. So, I mean, no matter what, I'm grateful for that. And yeah, I mean, it was a lot of fun. And I agree in a roundabout way. Don't just believe it. You're told to go out in the field and look for yourself. And that's really all my thoughts on the debate. So thanks, guys.
Well, it's my pleasure, Jackson and Brian. I look forward to your upcoming events as well. Brian, your upcoming debate on another geology related topic, and Jackson, a couple of your upcoming debates as well. Jackson, I think you made an important point, a very true point, that these debates force us to study and dig deep. When I personally debate, I almost see them as an exam. And oftentimes I learn the most about these topics when I'm actually preparing for a debate, do the debate, and then of course reflect on it, how I could have maybe responded better, what points were brought up. And so what a way to learn. I love it. Mm-hmm. So Brian, Jackson, excellent job tonight. Great debate. We got some positive feedback here. For example, Ashley Myers, good to see you, sister, as always. One of the best the great Grand Canyon debates I've seen so far. Amen. I love it. Both men were prepared, that's for sure. And that makes for a good debate. We rescheduled it a couple times, but I said last week, that just means it's going to be more worth the wait. And you guys did not disappoint. I love these technical, thought-provoking debates. So again, lots of good feedback. I'm glad to hear that the audience enjoyed it as much as I did. And to the audience, thank you again for the interaction, the participation, the questions, the challenges, the objections. They always help to make the debate that much more fun and that much more comprehensive. So thank you so much for tuning in. Brian and Jackson, thank you so much for your time and giving us a memorable debate on the Grand Canyon, as Ashley just said there. And okay, we'll talk and see everybody soon. God bless you all. Standing for Truth is signing off.